While the Cold War was flaming up in the 1950s, two of the most famous Russian helicopter design bureaus, Mil and Kharkov, were instructed by the Soviet government to create a new heavy-lift helicopter. One that was not able to carry just heavy, but also bulky cargo like ballistic missiles and their launch platforms, but able to over long distances. Mil came up with a somewhat traditional design, while Kharkov had other ideas entirely. It would be an aircraft that would be far more complex and risky, but could possibly surpass requirements set by the government and make a name for the Bureau for generations to come. And boy, did they have huge plans for what would come after. This is the story of the potentially great aircraft that came at a great cost. The unconventional super helicopter, the Kov K22. By 1953, the USSR had started the development of a new type of heavy-lift helicopters. Helicopters had proved their worth throughout the early beginnings of the Cold War. The Soviet Union was investing heavily into helicopters as the vehicles were highly useful throughout its vast wilderness across its continent-spanning country. Both Mil and Kharkov were selected to come up with designs, and the race was on to develop what would be at the time the world's largest helicopter. Its requirements would be simple: big, fast, and powerful. Mil had success with already in production designs such as the Mi-4, while Kharkov was struggling to make a name for themselves in the Soviet military circles. The K-25 and their coaxial rotor design would become their springboard to success, but at the time they thought the big break would be with the new heavy lift helicopter program, so they went all in. Kharkov would base its design initially on the Bartini B11. They figured that if the twin rotor helicopter was larger, then you could fit two horizontal propellers under the wings, and ta-da, a monster helicopter to inspire fear in the West. Here's how it would have worked. The K-22 would have two large engines fixed on each wing tip. These engines would power both four-bladed propeller and a four-bladed main rotor, operating them for either vertical or horizontal flight. Not at the same time, however. During vertical flight, the horizontal propeller would be disconnected, only coming online when the aircraft switched to forward flight. But these rotors were allowed to spin naturally, but without power. These engines on the wingtips would be badass, having up to 5,900 horsepower. The blades themselves would be able to push the aircraft up to a planned 400 km per hour, although during tests it only achieved a still impressive 356 km per hour. The four-crew cockpit would sit above the nose of the aircraft, with seating for a further 80 soldiers in the rear. If not men, the K-22 would be able to carry 16.5 tons of bulky cargo, with the nose of the aircraft swinging open at airfields for quick loading and unloading. Construction started off using the Li-2 fuselage as a base, but the engineers ended up scrapping it for a costly new airframe, delaying the program somewhat. In 1959, the first prototype rolled out of the workshop, fired up its engines, and took to the sky, its roar heralding in a new age of Russian helicopter. Also, the brilliant minds at Kharkov thought, in reality, the project was doomed as soon as the rotors began to spin. In 1961, the test pilot of the first flight, Dmitry Yefremov, would go on to break the world record for gyrodyne speed and set it at 356 km per hour. Among that one, several other world records have been broken with the same aircraft, some of which stand to this day. The one record that they didn't break, however, was beating Mil to the punch with a first flight. Their rival, who you may remember was also going for that same lucrative heavy lift helicopter project, had already flown their aircraft in 1957. But this would only be a footnote in history compared to what happened a year later. In 1962, while testing one of the 4 prototypes, the aircraft rolled to the left and crashed, killing all on board, including our hero Dmitry. The flaw was discovered in the starboard rotor collective pitch control linkage, and further inspection found that 2 of the other 3 K22s suffered from similar problems. A complicated autopilot feature had to be built just to correct this issue for the rest of the aircraft. Testing continued, but in 1964, a second prototype crashed. It had entered an uncontrolled turn to the right and into an unrecoverable dive, killing 2 more test pilots. Because of these 2 crashes and the fact that the aircraft was super complex to build and hard to fly, the government decided to pull the plug, and the Mi-6 went on in history to become one of the popular heavy helis of the Soviet Air Force. But this idea of a super heavy helicopter that had aircraft engines couldn't easily be shaken. Kharkov had one more design that would be faster, bigger, and even more powerful than the K22. In 1967, the Kharkov Design Bureau decided to have another crack with a project simply called the Kharkov K35D. This version would be huge and was designed to work in tandem with the impressive AN-12. A big difference between the K22 and this monster was its twin turbojet engines. This would increase its speed up to 550 km per hour and its lifting capacity to over 20 tons. These engines would give it a range of around 800 kilometers, which would make it perfect for deploying troops, up to 100 of them, to remote locations from air bases. Models at the time even feature the aircraft taking on board SAMs or other lightly armored tanks, so you know they meant business. For military use, they included a remote cannon on the nose, turning this into a literal gunship. Likely, had it gone ahead, there would have been a possibility for a more kitted out version with even more ornaments. However, this project never saw the light of day, with the concept once again going to the Mi V12, which a prototype was made and also broke several records in the helicopter world but ended up in a museum. The insignia number 35 would be reused by Kharkov for a different type of rotorcraft, with the latest development of the famous Ka-31 helicopter bearing that 35 number as a variant. After many years of producing helicopters for both the Russian Navy and the Air Force, with its amazing Ka-52 Alligator, the Bureau would return in 2019 with a project directed towards the civilian market and a long-time wish for a successful aeroplane-helicopter hybrid concept called the Ka-92. Along with the twin coaxial rotors in line with traditional Kharkov thinking, it would also have twin pusher propellers on the rear, just like the initial second design of the Ka-35. Slated for prototype development in 2018 and production to launch in 2022, the lack of any progress can only be blamed on the Russian market downturn of 2015, which saw many ambitious aviation projects hit roadblocks. A roadblock that seems to have hit every type of civil helicopter/plane aircraft, from the British Fairley Rotodyne in the 1950s to the Ka-35 and our very own humble Ka-22. The Ka-22 occupies an unusual junction in the world of aviation. Not quite a plane, not quite a helicopter, and not quite the revolutionary aircraft that would change the way we fly. But it still holds a very special place in our hearts, and we are happy that Kharkov continue to pursue their wild and unusual designs into the future. Speaking of the future, if you want to see future episodes of Found and Explained before anybody else, then why don't you become a Patreon or a channel member? That's right, that little join button down below. You can jump on there, see videos early, speak with me direct, and even come up with ideas that we'll cover next. So I'll leave a link in the description and you can check it out. Thanks again so much for watching. In the year 1972, the Soviet Design Bureau, MIL, embarked on an ambitious journey. The goal? A tilt-rotor aircraft to replace the Mi-8 in the future. Experienced with their own work on the Mi V12 and inspired by Kharkov designs, the idea was pretty straightforward. But as we know today with aviation projects, ideas is often not enough. Let's go see why the Soviet offspring never took to the skies. Ever since World War II, this one concept has been very intriguing for the engineers on both sides of the Iron Curtain. That is, building a very fast helicopter or the equivalent VTOL transport plane. And you know that it was the Nazis that actually tried first, but that's a topic for another day. The British built their famous Farley Rotodyne and the Soviet Kharkov Bureau built the Kar-22, but the Americans had a different concept. Unlike the two pair of engines for vertical and horizontal movement, a concept that both the British and Soviets explored, Bell created a tilt-rotor aircraft called the XV-3 in 1955. It would have the ability to take off like a helicopter and then rotate to become a plane. Jump forward a bit and we're now in the 70s and where our MIL story starts. After their attempts with the Gyrodyne and the hybrid helicopter concepts like the Mi V12, the Soviet spies went over to Bell for, let's say, inspiration on this new project. This time, their transport helicopter project would base its design on the tilt-rotor engine concept. So how exactly does this work? Well, to put simply, during the takeoff, the engines would be tilted upwards and the aircraft would be controlled similar to a tandem rotor helicopter. After gaining altitude, however, the engines would rotate into a horizontal position and the aircraft would then have transport aeroplane performance in terms of speed. For example, the Mi-8 would fly at around 220 km per hour with a maximum speed at 250 km per hour. In comparison, the Mi-30 projected top speed was somewhere between 500 and 600 km per hour, a significant increase over the traditional helicopter. To put this in an even greater perspective, the V-22 Osprey's top speed stands at around 509 km per hour. And the Kar-22, the previous Soviet Gyrodyne project, achieved a class record speed of only 356. So you can understand why this tilt-rotor concept was so interesting and so exciting for the Soviets. With the main idea behind this concept ready, the MIL Bureau got the TSAGI behind them and started work on the project. And as we previously mentioned, the goal of this project was to replace the existing Mi-8s. But greed and unrealistic requirements would prove to be the roadblock on this project very soon. As this aircraft was supposed to be greater than the Mi-8, it was important that they had a good starting off point with the original. The Mi-8, the ultimate workhorse for the Soviet and Russian Air Force, among with numerous other countries in its base variant, had a capacity of 24 people and 4 tons of cargo. The Mi-8 was then seen as a downgrade, only carrying 19 passengers and 2 tons of cargo, slightly less than the helicopter it was set to replace, but with a much greater speed as a payoff. Test radio-controlled aircraft were made and the development was well on its way when the government included an additional requirement. They needed 32 passengers and up to 5 tons of cargo. This was a hard hit on the MIL engineers and they quickly had to come up with a solution so not to lose funding. Instead of 2 engines, now there would be 3 Kilmov TV3-117F engines, the same ones that were used on the Mi-28 down the line. This would give it a total weight of the aircraft that was moved from around 10 to 15.5 tons. But just when they thought that they could finally put it off and bring this aircraft into reality, Moscow once again issued new requirements. Now, you need some background information to understand what exactly was going on in Moscow at the time. In the early 1980s, the Mi-30 project would end up being defended in front of a commission from the Ministry of Defense, who would not issue them their funding unless this one requirement was included in the development. By this time, the war in Afghanistan had heated up for the Soviets, and they understood how dangerous it was to fly a helicopter in the mountainous regions of Afghanistan, especially with the enemy being given stingers by the Americans and their helicopters being relatively slow and easy to shoot down. Having a multi-engine fast aircraft that doesn't require an airfield would be the best possible solution to save lives of troops and ease resupplying of bases and posts scattered in the harsh mountainous environment. On the other hand, this would have been the perfect aircraft for the airborne forces, the VDV, which was deployed in Afghanistan in large numbers. So what exactly was this development problem that we mentioned? Well, the government wanted a 2-engine aircraft, not this new 3-engine one. So once again, it was back to the drawing boards. To fix this problem, the engineers went with 2 massive D136 engines, which were powering the beast called the Mi-26, the largest production helicopter in the world. And now these engines would be used for the Mi-30 because they were the only ones big enough to be suitable for this type of aircraft. However, massive engines meant everything else would become, well, massive. This means that the weight of the aircraft was brought up to a further 30 tons. Remember, this was 3 times the original requirement and almost 2 times the weight of the V-22 Osprey. With this third and final design change, the project was finally granted funding and Mil got to work building this new monster helicopter. Unfortunately, something else happened in 1991. By the early 90s, the Mil Bureau had finally had the project sorted out, and with all the experience they'd gathered through the years, they proposed 3 finalized designs for the government to choose for further development and serial production: 11, 20, and a 30-ton variant. But by then, the Soviet Union ceased to exist, and with it, the project died as well. 20 years of development went down the drain, while at the same time, the US went into serial production with their own V-22. And you can totally imagine what it was like for the Soviet engineers to see this, their unfulfilled dream flying in the West and not in Soviet skies, just because the government couldn't sort themselves out and define the project requirements. Another thing to mention is just how the V-22 development was bumpy and how the aircraft even today isn't considered as the safest one. So would this project even make it into serial production in the USSR, even if they got the green light in time? I guess the moral of the story is, you can't please everyone, and certainly not the Soviet government. Hope you enjoyed this interesting story of one of the coolest looking aircraft designed by Mil. See you in the next video. You're not seeing double, you're seeing triple. In the early 80s, the Russians developed, in top secret, the king of all helicopters. One that was so big and so loud that it would have changed aviation forever. And it's likely the craziest helicopter concept you've ever seen. Weighing a shocking 150 tons, it was an aircraft made to carry, well, pretty much anything, and would have paved the way for the Soviets to conquer the far east of their empire, and perhaps even conquer the United States itself. But such an insane design should have an equally insane story behind it, and so welcome aboard the Soviet Flying Triangle, the Mi-32. Oh, and also side note, if you're loving this content so far, then consider subscribing and leaving a like. It helps out a lot. Siberia, and in general the territory of East and North modern-day Russia, is largely unpopulated and unexplored due to harsh climate conditions, lack of infrastructure, and endless forest. But here's the thing with remote locations. They happen to be extremely rich with resources and the perfect place to hide nuclear weapons. Hence, in the 1970s, the Soviet government issued a proclamation to manifest destiny the East and bring its full remoteness to bear on those degenerate capitalists in the West. And thanks to the Siberian terrain, the government was faced with a rising need for super heavy helicopters to carry building materials, people, and other construction equipment to remote areas. Helicopters available at the time, like the Mi-6 and Mi-10K, were not up to the task of transporting vast and heavy items, like generators or mining machinery. Thus, the engineers had proposed some interesting projects around this problem, like the Kov K22, which we covered before here on the channel, as a true next-generation heavy-lift helicopter. But at the end of the contest, it was the Mi-26 that was born as the solution to this Siberian problem, becoming the largest serial production helicopter to ever exist. But why stop there? The Soviets wanted more. The Mil Design Bureau, already very experienced with various helicopter projects, started working on something completely off the books. It was so insane that it was half an amusement and half a serious pursuit by the engineers, edging themselves to push the limit. The first idea behind the project actually came from the Mi V12. The engineers managed to create a large multi-propeller helicopter, and they were looking at a similar concept for the get-go, either by making a single fuselage with multiple propeller craft like the Chinook, or simply connecting two separate fuselages together. The second option prevailed, sort of. After all, if you can get away with combining two fuselages together, why not do three? The final design was shaped like a triangle made out of three fuselage segments, each of them having two Mi-26 engines, namely the Progress D136, and was able to carry cargo up to 55 tons. That's more than the weight of the fully loaded Mi-26. And let's talk about the size and design of this humongous thing. It was to be 40 by 36 meters, and that's not including the diameter of the rotors that would be spinning above the fuselage. Just by comparison, the fuselage was larger than that of the Airbus A320, so this helicopter was positively huge. The cockpit was located on the front section of the fuselage with a crew of 4, 2 pilots and 2 crew members to operate the cargo cranes. They would be situated below the pilots, very similar to the Mi-10K, for better visibility during the cargo loading or detaching operations. The maximum range of this giant was only to be up to 1,200 kilometers, but it would surely be enough for a special cargo that it was to carry. The cargo itself was anchored on 3 points, each on one of the fuselage segments to provide maximum stability during flight. It would hang in the middle, either leveraged sideways for optimum airflow during flight, or strung vertically to help fit into tight areas. You could imagine it carrying an ICBM and lowering it directly into the launching mechanism, something that other helicopter designs to this day are unable to do. So as you're probably asking yourself now, after watching all of this 3D animation, how the heck would this thing even fly? Hey, don't forget that I have a new channel all about space travel right here. This week's episode will be all about NASA's crazy 1960 ambitions for the solar system, so be sure to check it out after this video. Normal helicopters use a rotor on top and a tail rotor to control their flight. Bigger helicopters, like the tandem rotor helicopter such as the Chinook, are able to avoid a tail rotor by using the secondary rotor as a steering wheel, by having each rotate in different directions. These counter-rotating rotors eliminate the need for an anti-torque vertical rotor, allowing all power to be used for lift and thrust. The ability to adjust lift in either rotor makes it less sensitive to changes in the center of gravity, which is important for the cargo lifting and dropping. This dual setup also is much more stable during hovering mode, and if one of the engines fails, the other can drive both rotors. So what about our tri-rotor helicopter? You can't have one blade turn opposite if there are another two going the other way, and then it wouldn't be in balance. Or can you? You see, tri-rotor helicopters are not new. In fact, it was the British who first came up with one, and it actually flew, which was then the world's largest helicopter, the Kiev W11 Air Horse. Its three rotors would actually all spin in the same direction, but were aligned to avoid the influence of torque on the fuselage. For the Soviet Mi-32, a similar design would be used, with each rotor changing speeds depending on the current flight path. Without computers, done manually by the two pilots. Man, these Soviet engineers really were insane. So the Soviets had the plans, the means, and the reason. Why wasn't it built? When the Mil Bureau was previously developing the legendary Mi V12, the largest helicopter ever made, the project proved to be too complicated, very hard to pilot, and not really feasible for serial production. Kharkov failed with their super heavy lifter, the Kar-22, and also further with the Kar-35 design, and the Mi-26 was already built and in service. So a crazy flying triangle thing wasn't really a top priority, even though it would have been something like a distant helicopter brother to the Antonov AN225 at some point, being unique in carrying extremely heavy or bulky cargo by air. Plus it could carry the Mi-26, which in turn could carry its smaller counterpart, a real-life Matryoshka doll. Nonetheless, Mil actually did end up presenting the concept to the authorities in 1982 with a plan for serial production by the end of the decade. However, a change in government during the mid-80s in the USSR saw many aviation projects cancelled as they focused on more important things, like a failing economy. Just like many other interesting Soviet projects, this one also died along with the USSR. With no large government funding, nor a reason to develop a large helicopter, its only purpose was to end up in a found and explained video. So maybe subscribe, so all that hard work didn't go to waste. They say you can hear it before you see it. Cruising over the deep Siberian wilderness is a terror that defies imagination. Its 6 rotor blades, powered by 24 turbofans, generate an inhuman sound as it prepares to launch its 6 nuclear-tipped surface-to-air missiles. With mobility, range, and the ability to deploy anywhere, even in the sky, the vast territory of the USSR is finally safe from Western intruders. And for the situation where offensive abilities are required, the platform can even be swapped to carry troops, supplies, or even a basing platform for several VTOL Yak-38 fighter jets, making this 20th century helicopter a real-life helicarrier. I present to you in this week's episode the most insane, never-built helicopter, the Yakolev VVP-6 mobile SAM site. The USSR had a big problem in the 1960s, and when I say big, I mean bigger than any other country in the world. Because their territory was so vast, they required a way to keep their borders secure. And considering that during that time the US was infiltrating their aerospace consistently with U-2 spy planes, the Soviets needed a way to stop these pesky Western sticky beaks. But the issue with fixed air bases or other conventional solutions, like surface-to-air missile bases, was that they couldn't be everywhere at once. Helicopter designs had the flexibility to fly long range at a moment's notice and land anywhere, but the Soviet Union didn't have a helicopter platform big enough to fill this solution. Thus, the government turned to its various aviation ministries to come up with a solution. Enter Project GDP-6. Started by the Yakolev Bureau, Project GDP-6 proposed the construction of a heavy, multi-rotor helicopter designed to carry special payloads. And boy, do we have to talk about just how insane this aircraft was that they came up with, if you can even call it that. Its official name, like all things USSR, was simply called the VVP-6, and it would have had a very basic elongated shape 49 meters long and 6 meters wide. In the nose was the cockpit, either piloted by 2 crew members or computerized depending on the role of the aircraft, such as missile launching, and it would have a square fuselage throughout and allow it flexibility with its cargo carrying capacity. Now you're probably looking at this and realizing this aircraft wasn't aerodynamic and would fly like a brick. But you bet with 6 rotors, fuel consumption was the least concern on their minds. While we don't know for sure, we can estimate that its carrying capacity was in the region of 45 to 50 tons, based on the prospective cargo it was pitched with. To do this, it would have been powered by 24 turbofan engines with 12 on each side and 4 motors each, that would in turn activate 6 contra-rotors. In simple terms, they would rotate in different directions to prevent the aircraft being pushed in the wrong direction and fly straight. The 6 blades of the rotors were deliberately short as to not interfere with the cargo stored on the main tray, which I'll get to in a moment. Its range could be modified by adding more fuel tanks to the bed of the car, and the helicopter could turn depending on the individual speed of each rotor, negating the need for a tail. The landing gear could be stowed and retracted when not in use. Part of the advantage of this design was in fact that the VVP-6 could carry and even use existing surface-to-air missiles, such as the V-750 or Guideline SA-2 missile. It could store 6 for transport or a moment's notice launch them, even while in the air. Although more accurately, it would bunker down in a remote forest location and track the unsuspecting Western spy planes on the surface up to a range of 40 kilometers away or to an altitude of 30 kilometers, just shy of 100,000 feet. The various systems for launching, such as radar, missile control, and rearming, were stored in the front cabin of the helicopter or built into the fuselage. Apparently, the design also said it had the ability to store additional missiles, not just the 6 on the tray, but a casual look makes us confused where exactly they would be stored. But why stop there? The wacky engineers who came up with this concept had even more grand plans for this design. The aircraft was also created to carry more than just rockets, with further variants planned to carry troops into battle, resupply runs, cargo transport around regional areas, and even as a base for VTOL fighter jets. That's right, this bad boy was a real-life Avengers helicarrier, with the aspirations that the Mark II versions of this design would be able to accommodate several Yak-38 VTOL fighter aircraft, potentially launching, rearming, and refueling these aircraft whilst in flight, which is a bonkers concept. Operationally, the VVP-6 wouldn't operate on its own, but with a team of several taking on the role of missile launchers, others carrying control operators, and some sporting large radars. And if there were some VTOL fighters included in the pack, they would be used to defend the sites as well as run interference against bomber escorts. The program was a big success and had several huge advantages. For one, the VVP-6 could fly anywhere, making it utterly superior to ground-based SAM sites. It's easy to imagine how fast the helicopter could go to a remote position and overtake any surface-to-air missiles that were being carried by traditional machines trawling over the remote landscape.
carrying more rockets, and its mobility would render current SAM technology obsolete overnight. Plus, with a bit of tweaking to the design, the aircraft could carry far more than ground-based transports, and would have considerable application throughout the USSR, from Army to Navy to even the Special Forces. So, why was it never built? Just looking at the design, you can already see a huge roadblock: excessive complexity. Using 24 engines to power 6 rotors was insane. It would have been a record among all the creations of the era, and even in world history. The domestic market could not supply that many machines for a full complement of these aircraft carriers, and designing it would have been such a huge engineering mountain, taking years, if not decades, to develop. Plus, I bet the aerospace whizzes in the comments have already seen an issue with missile launching. If a fast-moving plane like the U-2 flew overhead, how would the aircraft rotate the missiles for launch? Because the rockets were so tightly packed on board, it would require the whole fuselage to rotate 180 degrees in order to track the target, which by that time, the enemy might have already escaped. There was also a flaw with the concept of a flying SAM sight. It would stick out as a sore thumb for the enemy to target. It would be easy to detect on radar, as if you wouldn't hear it coming with the 6 blades, and could be shot down with very simple anti-aircraft weapons. Ground-based SAM sights, on the other hand, were much harder to hit and even harder to detect. With the cancellation of the Yak-38 VTOL aircraft, and the obvious flaws of using it as a flying SAM sight, the program didn't get very further than wind tunnel tests. The original project hypothetically solved the operational task with flying colours, but making it a reality proved to be too much and was considered hopeless. The Bureau didn't get permission to take the design further, and it was shelved deep within the Kremlin until well after the fall of the USSR. Had it been built, we might have seen many more applications of heavy-lift helicopters used throughout the world. We might have seen the concept turned over to a passenger transport, or even a Western counterpart based on the Bell X-22 VTOL concept. But thankfully, that dream of a monster helicopter stalking their prey among the forests of Siberia never came to be. Wow, what an insane concept! Leave a comment down below if you think this was a good project, or a totally bonkers one that should have never been considered. I'd love to know your ideas, and I do read every comment. Special thanks to my Patreons who suggested this topic today. If you want to suggest topics like this for the channel, then you can either make a pitch in the Discord, which I'll leave a link down below, or you can subscribe to my Patreon and ask me directly. You will also gain access to videos early, behind the scenes, tutorials, and be listed right here in the credits. Thank you again so much for watching.
Ground effect based aircraft carrier carrying not 1, but 2 it's even better, spacecraft on top of its fuselage. This Soviet Ekranoplan is not just an aircraft carrier, but it's also a launch platform made to carry the mothership and small orbital ship overseas to a launch location and send them to the stars. We've done some pretty crazy stuff here on the channel, but I promise you, this is beyond anything you have ever seen. Today, we'll be talking all about the Sea Launch Ekranoplan. By now, everybody knows what an Ekranoplan is, but if you don't, flashback time. The brilliant solution to sea transport is based off something called the ground effect. This made extreme speeds over the sea possible, and transporting huge amounts of cargo over long distances in a quick manner a routine job. Goodbye boats. Both the Soviets and the Americans experimented with the idea of an aircraft that utilized the ground effect, but the Soviets made much more advancements in this field, and they were the first to create the insane KM Ekranoplan, also known as the Caspian Sea Monster, which was under the veil of secrecy long before being discovered by Americans during the Cold War. Flashing forward, what followed was the Lun Ekranoplan, which was fitted with anti-ship missiles and had the role of a ship hunter aircraft, undetectable to radar, and which could perform hit-and-run attacks. But the death of the defense minister Ustinov in 1984, all the funding was cut to the Ekranoplan programs, and the one operational Lund-class Ekranoplan and 3 A90 small vessels were the only ones left in service for the next decade. But that didn't stop the mad lads at the USSR from coming up with some truly insane ideas for Ekranoplans. And it's this huge one that we're talking about here today, designed to beat America at the space race. Americans with their famous space shuttle and Soviets with their Buran hoped on a new trend that promised the glorious future between the stars. You see, firing rockets is insanely expensive, and having a multiple-use vehicle was the solution. Both sides had an aircraft that could carry their new spacecrafts, like the Boeing 747 Space Shuttle Combo, or the main reason why the AN-225 was ever built. It was made to carry the Soviet Buran. But the idea of an air-launched space vehicle was also being explored, with the Soviets and their MiG-105. Yes, that's the space MiG that's coming up on the channel very soon. You see, what made the Ekranoplan an interesting launch vehicle idea was the fact that the best place on Earth to launch something into space is, well, the equator. It's well known that up to 2 times more fuel is needed to launch a rocket from the northern or southern hemisphere, and the cosmodromes for both the US and the Soviet Union were built in the south of their respective countries so they could be as close as possible to the equator. But scrapping all this, what if you could simply launch from the equator itself, without having to invade any country from international waters? Project Sea Launch was made exactly with this in mind, with assembling rockets in the middle of the ocean not being an easy task, but assembling an orbital vehicle would be an impossible one. But that's where our friend the Ekranoplan comes in. Our Ekranoplan carrier would be powered by 6 engines total, out of which 4 would be used to take off and reach the ground effect height, and the remaining 2 for the flight itself. The total weight of the Ekranoplan and the spacecraft on board was around 750 tons, which compared to the 550-ton Caspian Sea monster wasn't that far-fetched. The aircraft would have a double fuselage connected with a flat surface where the spacecraft would be mounted, and a double tail to give it room to the spacecraft, just like the AN-225. Sitting on top of the carrier fuselage, the spacecraft was actually in 2 parts. The first part was the mothership, and then a small orbital craft would sit inside of it until it launched. The mothership was powered by a further 6 ramjet engines, and the orbital aircraft had 2 rocket engines, and the overall design was based on the delta wing meets flying wing concept. But as you may or may not know, ramjet engines have one issue. They can't start off on the ground. They need to have a running start, or more precisely, they need to have air rushing into the engine so it can get compressed and then combusted before shooting out. Ekranoplan's top speed was projected to be around 550 km per hour, which again was quite realistic compared to the 500 km per hour for the Caspian Sea monster, and it would give the ramjets more than enough of that initial speed needed to operate. When the engines were started, the spacecraft would detach and use the ground effect to gain more speed before turning upwards and gaining altitude. Once it reached a high enough altitude, the orbital craft engines would start and they would take it into Earth's orbit. The orbital craft itself would weigh around 100 tons, which is comparable to the Buran's 92 tons, or the Space Shuttle Orbiter's 100 tons. So we could expect a similar layout with a payload bay in the center fuselage and probably similar capacity. So this thing was absolutely huge. Just how big, you might ask? Well, this whole thing would have certainly been massive. If we look at the Caspian Sea monster, that was 92 meters long and 37.6 meters wide and had a height of 22 meters. So this Ekranoplan would have been at least 25% more larger than this aircraft to support the weight of the mothership and its orbital craft, along with massive wings, unlike the somewhat small wings on the Caspian Sea monster. Anyway, back to the story. The mothership could return back after launch, with one option being landing at a nearby airfield, but also landing on the Ekranoplan itself, which would have been possible looking at the tests and calculations made with the models, although it would have been extremely hard. Now, the first issue with this idea is the fact that the original KM Ekranoplan operated only in relatively calm weather within the closed sea, like the Caspian one. With an ocean, you can never expect the same calm seas, and it would be very difficult to fly and operate the carrier itself. The engines are also placed in a way that there is any issue with them, the spacecraft would be in harm's way and destroyed or damaged immediately. And then we need to talk about the launch itself. If the spacecraft leaves the ground effect height before achieving the required speed, it would crash immediately, and flying on top of the Ekranoplan and matching speeds when landing would be very difficult. Unlike the KM and the Loon class, this design didn't have any additional side plates on the wings to reduce wingtip vortices, which would induce more drag. The project also requires the engines to produce thrust of 30 to 35,000 kilograms force. If you compare these to the most powerful Soviet engines of the era, the Kuznetsov NK-32s, which power the Tu-160, they were still some 5,000 kilogram forces short. So completely new engines would have also needed to be developed, and we all know how Soviet projects that didn't have an engine ended up going. Along with the development of the Ekranoplans, a couple more interesting options for its future usage popped up. The United States wanted to build a civilian passenger Ekranoplan, and the Soviets developed the insane VVA-14 submarine hunter, and they even thought to create an Ekranoplan aircraft carrier to patrol their sea borders. But all of these ideas, including the sea carrier, sound totally insane. How on earth was the ground effect supposed to carry the sheer weight? Well, you see, the ground effect allowed wings craft to experience significantly reduced air drag when flying low over the surface of the water. And ground effect is not just reserved for Ekranoplans, all aircraft experience this, and that's why you can sometimes see aircraft flying low before pitching the nose up when they gain speed. In our case, this would allow the KM to fly once achieving the ground effect height with only using 2 of its engines. This is impressive because it was a 540-ton beast, not much less than the largest aircraft in the world, the AN-225. And although slower than the Antonov, it allowed for much more room to upscale the thing compared to a standard aircraft. And it's the upscaling that's the critical term here. That's how ideas of the Ekranoplan aircraft carrier came to be. With enough engines and thrust, you could have an entire aircraft launch platform on the sea. But this would never come to be. The Ekranoplans died out in the 90s, and the KM crashed all the way back in 1980s, and this massive beast would have been insanely hard to operate, and the issue of weather and operation in the middle of the ocean persisted. But as we said, it wasn't just the only crazy Ekranoplan project that the Soviet Union came up with, nor the Americans. So be sure to check out our videos on the American Ekranoplans, and do let me know if you'd like to see Bartini's ground effect aircraft carrier. Hope you enjoyed this one, and I'll meet you next week with a new Found and Explained adventure. In the late 1950s, there were rumors of a radical new aircraft design from deep within the USSR. It would be a flying boat that could fly vertically, carried the biggest nuclear weapon the Soviets could muster, and had its own Parasite fighter capable of scouting, defense, and independent strikes. This flying monster could land anywhere, from water to desert to snow and ice, and would be refueled from submarines in remote lagoons and lakes, all with only a crew of 3 and a range to reach the distant shores of the United States. But this incredible concept from an even more incredible engineer never happened, and the USSR passed on what could have turned the tide of nuclear fever. Welcome to the most overkill bomber aircraft ever designed, the Bartini A57. Oh, what's this? A passenger plane piloted by cute puppy dogs and carrying candy for all of us? Oh no, that kitty fighter jet behind it's got its target locked. He's going to shoot it down. Unless one of you people that hasn't subscribed to the channel clicks that red button right now in 3, 2, 1. Thank goodness, someone saved the day. Anyway, back onto the show. By the late 1950s, the Cold War was at full thrust, pitching the military might and the scientific minds of the United States and the Soviet Union against each other. The arms race between the two superpowers was at fever pitch, and it looked like things might be heating up very soon. The atomic age was well into its maturity, and both countries were frantically developing new and horrible ways in which to deliver intercontinental ballistic missiles or nuclear payloads. The Bartini A57 was one such project by the USSR. Envisaged was a massive sea-launched intercontinental bomber that wouldn't need to take off from land-based airfields, which were always much more vulnerable to enemy attacks and reconnaissance. How the Bartini A57 bomber was designed to achieve this was inventive to say the least. The way in which it would take off and how it would be fueled were just two of the innovations devised by the A57 concept. And there's a good reason why the Bartini A57 has been dubbed a beast of an aircraft, given that it was technically a flying boat. Let's dive right in, shall we? First things first, the A57 was designed in 1957 and would have hauled a 244N thermonuclear bomb on board. That is very important for the time, given that 1957 was slap bang in the middle of the hyper-paranoid atomic age and escalating arms race. Even though it was a large bomber carrying a city-destroying nuke, it would have only needed a crew of 3. The A57 would weigh in at 320 tons or 705 pounds, have a length of 69.5 meters or 228 feet, and a total wing area of 755 square meters or 8,127 square feet. Importantly, although designed to avoid land-based airfields, the A57 was indeed equipped with skids for aircraft landings if it needed. The aerodynamic configuration of the A57 was quite revolutionary for its time, particularly with regards to its long swept wings. The leading edge of the wing had a sweep angle which became stepped, thereby simplifying the wing's load-bearing surface. It also created what is called a self-balancing wing. This feature of its wings enhanced the aerodynamic capabilities of the aircraft, allowing it to reach subsonic and supersonic speeds with relative ease, especially for a large flying boat bomber of that era. This design of the wing would later be known as the Bartini wing. For takeoff from water, the aircraft was also fitted with a ski chassis consisting of hydroskis and underwater wings. The landing gear not only allowed the A57 to land on and take off from both water and the ground, but also from snow and ice. It is believed that the A57 could take off from any unpaved airfield with a runway not less than 3,000 meters or 9,500 feet long, as well as a smooth, snow-covered strip with a length of 3,600 meters or nearly 12,000 feet, without using its accelerators. So as you can see, this plane really was designed to take off from anywhere at any time. On that last point, it's worth noting that this ability to take off from snow and ice would have also made it possible to use forward-based airfields on drifting icefalls located in the Arctic region, or even icebergs that drifted south down into the Atlantic Ocean. The larger version of this aircraft was called the America, and that's with a K, and hence the A designation in the A57, as its intended target was obviously the United States. A smaller short-range flying boat was also designed which could reach targets in Europe that were closer to the Soviet Union's borders, and it was named the Yi-57, with the YE derived from the Russian word for Europe, which is Europa. Let's explore what a typical mission would involve with the A57. As stated in the video by my handsome voice not less than 30 seconds ago, one of the innovations of the A57 was the way in which it would take off. It would achieve this with the use of vertical jets for needed thrust and lift. Highly economical and powerful turbojet lift engines were significant features of this aircraft given its size and bulkiness as a massive boat plane. The engine technology would be similar to that found on a vertical takeoff or landing or VTOL aircraft today. A lift jet is angled to provide an aircraft with an aerostatic lift instead of relying on pure or additional thrust for the aircraft to take off. That means it's an engine that doesn't require the movement of the air over the airfoil to generate lift, and hence is able to take off vertically when needed. The engines were logically positioned to face downward in order to assist its takeoff from water surfaces. The chosen engine was to be the NK-10B, or the P-10-B engine, which boasted an afterburner thrust of just 24,000 kilograms, or 52,000 pounds. With 5 such engines on board, the A57 should have been able to fly at a cruising speed of 2,500 kilometers per hour with a climbing height of 24,000 meters. Its maximum takeoff weight would have lied somewhere between 270 and 305 tons. The aircraft could take on a significant amount of fuel as well as its nuclear weapons to cover huge distances. So you're probably wondering, why on earth was this plane designed? As ambitious and perhaps even foolhardy as the A57 project sounded, there was relatively sound rationale for it conceptually. Well, at least if one considers what the aircraft designer, Robert Bartini, had to say. Bartini was of the opinion that there were key problems, or challenges if you like, that face strategic aviation, meaning that any military aircraft should deliver on the following. 1. It should be able to penetrate any point of the enemy's territory. 2. It should provide the least vulnerability possible from an enemy's air defense systems. 3. It should remain as hidden as possible before reaching or attacking its target. 4. It should be able to approach from any tactical advantageous area such as snow, ice, ground, or water. And 5. It should be independent of stationary runways and launching grounds that are costly and leave military assets exposed. Bartini made some very good points in his estimation of what is needed for an ideal military aircraft. And in his mind, the A57 came closest to achieving the objectives needed to overcome that list of challenges. In particular, the A57 would be perfect for achieving its 5th challenge, namely ensuring that fixed, land-based runways could be avoided, if not obsolete. But what of that little fighter jet that we have seen so far in all these 3D renders? Later variations of the A57 design also incorporated a twin-engine jet known as a Parasite fighter that would serve as the escort and reconnaissance mate for the much larger bomber when doing sorties over enemy territory. This fighter jet, called the, and forgive me here in my pronunciation, the Saibin 2RS, which would later become the RSR, would be able to piggyback the A57, traveling at its top speed of 2,500 km per hour or 1,500 miles per hour. Together, the two aircraft could cover targets within a radius of 5,000 kilometers or a 3,107 mile radius. Interestingly, the Saibin 2RS baby jet would only need to use its fuel on its return flight. And by the way, it's worth noting that whilst the Bartini A57 was always a conceptual plane, the smaller Bin 2RS fighter jet did in fact already exist at the time. Also, an interesting aspect of the later RSR reconnaissance aircraft was that its dimensions and weight were very similar to that of a cruise missile, which of course was not by chance. Had it actually gone into development, we might have seen this plane carry or be a launching platform for bigger missiles, or perhaps even something to reach orbit. But we ain't done yet, because what they designed next was even more insane. Perhaps a more ambitious innovation for this bomber would be its refueling system. The plan, of course, was for it to be refueled by submarines. Yeah, you heard that right. Refueling this massive bomber would only be done by submarines out at sea. Commentators have noted that flying boats, which is essentially what the A57 bomber was, are not made for waves and require flat, shallow water on which to land and maneuver. The best places for them to do this is rivers, bays, or lagoons. Submarines, on the other hand, are the exact opposite. They hate shallow water and operating in relatively confined spaces such as rivers, bays, or lagoons, which makes them potentially more at risk of attack. Which begs the question, who thought it was a great idea to have a giant boat plane that was fueled from submarines? Well, that man was obviously its designer, Robert Bartini. It's worth spending a bit of time to discuss who exactly this man that the plane was named after, namely Robert Ludwigovich Bartini. He was originally from Italy, having been born from a noble Italian family. In his time, he would go to become a pioneer of amphibious aircraft and ground effect vehicles. The Soviets nicknamed him Baron Rosso, or the Red Baron, due to his noble descent. He had long been a member of the Italian Communist Party and fled to Moscow when Mussolini's fascists took over in Italy in 1922. He received Soviet citizenship and worked for the Central Design Bureau building seaplanes, and would become the head of the Department for Amphibious Experimental Aircraft Designs in Moscow. Unfortunately for himself, Bartini was in the habit of criticizing some of the policies and the leadership of the Soviet Union, and in 1938 he was arrested by the country's notorious secret police, or NKVD, on the ludicrous charge of being a spy for fascist Italy, the exact country that he ran away from. He would go on to receive a 10-year prison sentence, although he continued to work on new aircraft designs throughout World War II. Released from prison in 1946, he would only be officially rehabilitated by the Soviet state by the direct orders of the Soviet Premier Nikita Khrushchev himself. He would eventually be awarded the Order of Lenin in 1967. He published numerous papers regarding aviation construction materials, technology, aerodynamics, flight dynamics, and even theoretical physics. Bartini's effect, a phenomenon in aerodynamics where the drag is reduced and thrust increased when an aircraft propellers are arranged with two motors in tandem, was named in honor of Bartini himself, as he was the first designer to propose it. Bartini designed 60 different aircraft during his lifetime, yet only a few were actually built. Today, it's acknowledged that many of Bartini's designs and engineering ideas were simply too ahead of their time. Yet his much vaunted A57 bomber was not to be, even though on paper it sounded pretty fantastic. Why? There was a change of fortunes for aviation manufacturers in the USSR as the 1960s approached. Quite drastically and almost overnight, much of the focus of the country's military innovation switched from the armed forces to the manufacture of rocket technology. The successful launch of Sputnik 1, the world's first satellite in orbit in space, in October 1957 had stoked up the Soviet leadership with patriotic fever. The atomic age was making way for the space age, and the Soviets were increasingly spurred on by the challenge of beating the Americans out in space. The Kremlin had also realized that the development of ICBMs did not require the need for massive, hugely expensive bombers such as the Bartini A57. Those ballistic missile payloads could be far more efficiently delivered than that, as the 1960s quickly revealed. The good news is that not all work that went into the A57 was wasted. A little project known as the design and development of the Tupolev Tu-144 supersonic passenger aircraft, what would be the Soviet Union's answer to the Concorde supersonic jet, took off into the sky in 1960s, pun intended, and it's well known that all of the documentation relating to the 1950s A57 bomber project was sent to Tupolev by Moscow. Bartini's ingenious ideas would yet be put into groundbreaking effect. It seems fitting for an acclaimed engineer who spoke 7 languages and was also an astronomer, philosopher, physicist, painter, and musician. Bartini was the quintessential modern Renaissance man, and he joins a long line of other aviation heroes that create the modern world we have today.
This video is brought to you by my other channel, Aviation Station. The Antonov AN225 was just the beginning. The engineers had big plans for the aircraft, and by big, we mean huge. Meet the AN325 and its bigger brother, the Antonov AKS. They were templates for a new Soviet spacefaring future, from shuttle transport to spaceplane launches to even future designs that were somewhat wacky and out of this world. But with the news of the destruction of the one and only AN225 in Ukraine, it comes the end of an era, perhaps even the end of the last Soviet Union mega project. In today's video, we won't just be looking back at perhaps one of the most magical aircraft to ever fly, but appreciate the good that it did during its life and what could have been. This is the future that we never got. The AN225 began its life as a heavy-lift aircraft designed to carry the Energia rocket boosters and the Soviet shuttle Buran. Either way, up to 200 tons of cargo could be carried externally on top of the fuselage. Its configuration was much like the NASA Shuttle Transport 747 used by the United States to bring the shuttle back from the landing site to its launch pad. With 6 engines and a horizontal stabilizer wing that was bigger than most jets' actual wingspan, it was a striking image of raw power and, some would say, arrogant defiance of gravity. Other than the impressive external load capacity, the AN225 could carry up to 250 tons of internal cargo. Engines, generators, tanks, planes, or helicopters, you name it. During its long career, it broke many world records, like lifting the world's longest airlifted piece of cargo, or the world's heaviest cargo transported by air. And if you're wondering just how many passengers it could carry, I've actually already done all the maths right here. But the real advantage of having such a large aircraft that could be used not only just for transport, but it could be used for launching rockets as well. The AN225 by design was future-proofed. In the 1970s, both the USSR and America were pushing the limits of ground-based rocketry. But always a sticking point was going from zero on the ground into the sky, rather than actually reaching orbit. If a rocket could skip the first stage, moving from under the full influence of gravity to terminal escape velocity, that would mean far less payload for fuel and more for scientific, or perhaps military, endeavours. Hence the idea to launch from an aircraft instead. The AN225 being large enough to carry not just a shuttle for transport, but enough rocket fuel as well, could be used as a launch platform in itself.
Dubbed the MAX, the Multi-Purpose Aerospace System, this program was focused on developing a set of different spacecraft which could be used with the AN225 as a launch platform. There were three main variants: the MAX OS, which included a fuel tank, and a smaller manned MAX Molniya spacecraft with approximately 7 tons of cargo. Next, we have the MAX T, an unmanned version with a fuel tank which could be used to send heavy cargo into orbit, and the MAX M, which could carry a larger spacecraft like the Buran or the Tupolev OOS, which we'll talk about in a bit. The program was eventually cancelled in 1991, along with the cancellation of the other aircraft projects around that era, as well as the entirety of the USSR. But that's a video for a future time. But what if they wanted to launch something, say, a smudge bigger than a simple little shuttle? Well, they would have to start putting the word humongous in front of everything. In the 1990s, the British approached Antonov to produce an updated version of the AN225, one called the AN325. A plane with a super creative name that would have an additional engine on each side to a total of 8, with 4 of them positioned as pairs on the same pylons, a similar solution to the one used on the B-52. This humongous aircraft would be able to take the new British Horizontal Takeoff and Landing Spacecraft, or HOTOL, a single stage to orbit aerospace vehicle that you can expect us to cover very soon. The Soviets did extensive wind tunnel testing and concluded that the project would be possible, but the next year the USSR wouldn't even exist anymore and the project lost interest. This wasn't the end of the AN325 project, however. In 2005, it was actually the Ukrainians who started to think about the future use of this platform. Yuzhnoye Design Bureau and Antonov started working on a new spacecraft called the Successors, which would launch from the AN325 or the AN225. And if you didn't know, there's actually another AN225 fuselage sitting in Ukraine, but it was never completed. But I'll get back to that in a minute, because first, this piggyback ride to space is going to get even more crazier. Back in the 80s, during the one-stage spacecraft race, Tupolev Design Bureau was working on a completely new project called the Tupolev OOS, where OOS stands for, well, one-stage orbital craft. So we're talking here about a possible nuclear-powered, double the size of the Buran craft that could be launched from an aircraft. But not exactly the one you're thinking. Special note, these 3D graphics that you're seeing comes from Haze Grey Art, who is a fantastic 3D artist who does all sorts of wild and crazy spacecraft. So I put a link here and in the description for you to check out. You see, one of the launch options was from mid-air, or to be more precise, from an airborne launch platform such as the AN225. However, due to the massive size and weight of this new spacecraft, Tupolev and Antonov started to work on a new project called the Antonov AKS. Why this is so crazy, you may ask? This thing was proposed to be a massive double fuselaged AN225 built out of the 2 existing fuselages. It would have 18 D18T turbofans with a combined thrust of 420,000 kilogram force and be able to carry up to 1,650 tons or 3.6 million pounds. Its wingspan would be 153 meters or 500 feet long, twice that of the Boeing 777X we have today. Ironically, it would not even be the most insane aircraft planned by the Soviets during that era, such as the Molniya 1000 Heracles, which deserves its own video. As for the AN225, the future was bright and the dreams were big. But sometimes, dreams don't happen. And unfortunately, it's the part of the video where we have to talk about the present, rather than the future. As you may have probably heard by now, there is evidence that one of the biggest aircraft in the world, and the only one of its kind, was destroyed during the ongoing Russian-Ukrainian conflict. After the Russian troops stormed the Hostomel airport, which is used by the Antonov company and where the Miria was stationed, there was some heavy fighting over the next 2 days, and we got images of the AN-225's hangar, or rather cover, burning. Further satellite imagery confirmed that there was an aeroplane there, and we can say with fair certainty that the AN-225 is either damaged or destroyed at this point. What I'm about to show you next might be shocking for some viewers. The latest info we could find is a video where you see now, and it shows that the AN-225 is clearly destroyed and burned, perhaps beyond repair, although at least some of the engines might still be usable and could be removed. And now this is where that second fuselage comes into play. There's a complete second airframe of the exact same design that is somewhere around 60 to 70% completed, and it is likely stored at the exact same airport. In the past, the Chinese have been interested in buying and completing this second aircraft and using it as a heavy cargo transport platform, but the deal was never finalized. The owners themselves have said that the simple cost of $300 million and 3 years' time would turn this airframe into an actual aircraft. So again, we can hope that this airframe can either be used to repair the current aircraft or as a base to build a new one. No matter what side of the fence you sit on, you can appreciate the magic that the aircraft was. But perhaps since Mrya means dream in Ukrainian, we can now only dream for a brighter future for the AN-225, the Antonov Bureau, and Ukraine as a whole. (1988). Two state-of-the-art Soviet fighters are flying in formation, entering British airspace. But they're not seen as enemies, but greeted as friends, with no ill intentions. They're here to put on one of the greatest air shows the world has ever seen. As the pilots performed in front of the world audience, everybody was left with the same questions on their lips. Has the Soviet Air Force finally gained the technological upper hand over the West? And is the future of air warfare going to be decided by the Soviet Union? This is the story of perhaps one of the greatest fighter jets ever built, just at the wrong time, at the wrong place. Oh, and don't forget that we have an online merch store. Every week, new items. Foundandexplained.shop. The Vietnam War and subsequent Israeli-Arab wars flipped the table for the Soviets. On one hand, there was the great performance of the MiG-21s in Vietnam against the technologically superior F-4s, but on the other side was the subpar, oh who am I kidding, the actually terrible performance against Israelis flying the same jets. Scrambling for answers to this situation, the Soviets built a new training center called the 1521 in the airbase Mary, dubbed the Soviet Top Gun program, and the other was the development of a slew of fourth-generation fighters. But in classic rock, paper, scissors fashion, the situation quickly reversed. Just as the Americans were afraid of the Soviet MiG-25s, so now were the Soviets when they found out about the FX program and the next generation of fighters in the United States. Their response was a program calling for a light and heavy fighter which could share design features but perform different missions. This would be called the LPFI, or Advanced Light Frontline Fighter Project, and MiG was adamant to build another legend. After Viktor Belenko defected in 1976 and revealed to the West the facade under which the MiG-25 was hiding and gave them all of the latest electronics, Mikoyan and Gulevich had a very difficult task at hand. All design philosophy up to this point was thrown away and they needed to build this new jet from scratch. As per usual, when you've been around this channel for a while, the requirements issued by the Soviet government for this new fighter were extremely ambitious. The new fighter had to fly at over Mach 2, present extraordinary maneuverability for dogfighting, which was still very important as the Soviets had learned from the Israelis and experiences in Vietnam, but also have the ability to use BVR capabilities that would counter the new US missiles like the AIM-7 and their powerful radars. The Klimov Bureau was tasked with developing the new RD-33 engines, and MiG decided to go for a 2-engine option to give the aircraft enough power even though it was classified as a light fighter. Each engine provided some 8,300 kilograms force. When dividing with the weight of the aircraft, they actually got the thrust-to-weight ratio greater than 1, which would make it critical for its agility in dogfights. But they didn't stop there. This aircraft design implemented LERX, or wing extensions, that would go all the way to the canopy and hump behind the cockpit to house extra fuel and electronics. 2 vertical stabilizers would allow for better control and maneuverability, and the engines were then separated into 2 gondolas on the underside of the fuselage to increase survivability and ease maintenance and replacement. And thus what we know as the MiG-29 was born. The MiG-29 was not just an elegant airframe with good aerodynamics. This time, the Soviets wanted to pay more attention to what was under the hood as well. And trust me, this stuff is cool. It would have a new infrared search and track system called Kovs, which was mounted in front of the canopy and would allow the pilot to track in real time and fire infrared guided missiles on the enemy jets without using the radar. The MiG-29 was also the first Soviet jet to use composite materials in its construction, and the latest innovation was the helmet-mounted aiming system that would allow the pilot to lock onto enemy jets outside of his HUD and launch a missile, just by looking. Along with IRST, this was something that America would adopt only some 20 years later. New R-73 missiles would also make this new tech effective in combat scenarios because they were extremely agile with thrust vectoring systems and could be launched off-board while maneuvering, where the pilot could take evasive action at the same time. Bye-bye Maverick. The MiG-29 was a true dogfight beast. However, just as the Americans were wrong about the F-4, so were the Soviets with the MiG-29. And here's my controversial statement. The MiG-29 was never a bad jet, it was just never properly developed for its role. Soviet air warfare doctrine envisioned the MiG-29 as a frontline fighter, meaning that the new heavy Su-27 would perform long-range patrols and deep interceptions, where the MiG-29 would be tasked with fighting the remnants of an enemy air opponent, and supporting the CAS jets like the Su-25. Hence Phasertron, the company developing the N019 radar, decided to go with an old Cassegrain antenna instead of a planar array, based off the Sapphire 23ML. This made the radar less effective in tracking targets on longer distances and prone to jamming. It was equipped with the new R-27 missile, but the missiles themselves proved to be extremely unreliable. But let's not get ahead of ourselves just yet. The Soviets, still burning with rage from the defection of one of their best pilots a few years earlier, took great measures not to leak anything to the West. They even went as far as to have the engineers at the factory work in such shifts to avoid outdoor testing when American spy satellites flew over Moscow. Alas again, one man destroyed it all. Phasertron engineer Adolf Tolkachev sold the CIA information about the all-new Soviet electronics and missiles, including the radar for the MiG-29 and Su-27. For greed or peaceful glory, we don't know, as he was captured and shot in 1986. Stuck in a rut and needed to fix these flaws, the Soviets quickly redeveloped a modernization to the MiG-29A called the MiG-29 Izdalia 913 or MiG-29S. Radar was updated and additional jamming equipment was added to the enlarged hump behind the pilot, and the range was also extended by some 100 kilometers due to more fuel capacity. The 913 was equipped with air-to-ground weaponry as well and had the capability to carry nuclear bombs. So we arrive at the Farnborough Air Show in 1988 and the first presentation of the new fighter to the world. The Soviets already understood that the future of air warfare will require multi-role aircraft and not dedicated fighters, and so they started developing a new MiG-29M variant along with the carrier-based MiG-29K. However, they simply came at the wrong time after the Chernobyl disaster in 1986. And with the Soviet economy dwindling, such projects were at the bottom of the priority list and were soon cancelled, leaving the 913 as the most sophisticated variant when the USSR fell apart. But then came the bad track record for this jet. The Iraqi Air Force acquired MiG-29s during the invasion of Kuwait, and the USSR didn't provide them with any new R-73 missiles, and they flew old R-60s against Americans during Desert Storm. The MiGs lost all duels with F-15s and only managed to score one kill against the Tornado. Then in 1999, Yugoslav MiGs faced off against F-15s and F-16s and lost every single engagement, being blown out of the skies by new and extremely deadly AMRAAM missiles, having no chance without working radars and the ill-fated R-27s. And here's the thing about the R-27. In simple words, it was a terrible missile. Just like the US had problems with the AIM-7 during its early development, the Soviets had a terrible missile which proved to be ineffective even during training and testing at the Mary Air Base, or the so-called Soviet Top Gun School. During the conflict between Eritrea and Ethiopia that started in the late 90s, Ethiopian Su-27s with Russian Merc pilots faced off against Eritrean MiG-29s. Not a single Su-27 was shot down, while 5 MiG-29s were by much superior flankers. However, out of the 30-something launched R-27s during the conflict, only a single missile scored a hit. And then we've seen them in use in Ukraine, with the Ukrainian Air Force using MiG-29s in their updated Mu-2 variant during the current war against Russia. With the help from NATO, they managed to integrate AGM-88 HARM missiles and use it in SEAD missions, with some of them actually scoring hits on Russian AA systems in the Kherson region. They are also used extensively in fight against Russian drones, and Ukrainian pilots keep flying sorties to this day against all odds. However, in the words of the pilots themselves, the lack of proper mid-range AA missiles and the Russians using long-range R-37Ms make their mission pretty impossible in air-to-air combat. Integrating ARAM is very hard because Ukrainian MiGs are pretty old and Soviet system architecture doesn't support modern NATO missiles, proving that the aircraft really is obsolete at this point. But the saga of the MiG-29 is not over, at least not yet. It was none other than India that came to the rescue and ordered further development of the MiG-29K for their aircraft carrier in the early 2000s. Down the line, MiG developed the heavy updated K and M2 variants for the Indians and export respectively, and the latest modernization of the MiG-29 is now called the MiG-35, and it's the ultimate variant of this jet, implementing fly-by-wire controls, new radar, new set of weaponry and electronics, along with targeting pods. It's completely a new jet based on the same old airframe. And if you're interested to know the story of the last Fulcrum, let me know and I'll be happy to make a video about it. In the meantime, thanks so much for watching, and I hope you liked this video, so don't forget to subscribe and leave a like for more content just like this one. Thanks! September 1991. A new Russian Navy aircraft is landing vertically on the deck of the Admiral Grushkov aircraft carrier. Yakolev Design Bureau went all in for one last attempt to try and get back its old glory days of the Soviet Union. A new design that held 12 world records all the way from the prototype to its completed construction, but was doomed to fail from the start. Today we'll be talking about the aircraft that probably inspired the Lockheed and American engineers when designing the vertical F-35, and how its impact on Russian aviation is still felt today. This is Yak 141. Let's be clear, the Soviet Navy was never as good as the US one. The Soviets had a different doctrine centered around hunting US aircraft carrier groups and delivering nuclear payloads to them via submarines from distant polar regions. Thus, their naval aviation was, well, as you can guess, so far behind the US that the Russian Navy would be decimated in a toe-to-toe conflict. So in the early 1980s, they decided to change that. The Yak-38 was the main naval aircraft of the Soviet Navy and Kiev-class aircraft carriers, or should I say heavy aircraft cruisers per Soviet classification. Even in the words of Yakolev, it was always meant to be an interim solution. The construction and design of the Yak-38 was only meant to be a study to develop technologies and production for a more capable naval jet. So that time had come by 1975. The Yakolev Bureau got one simple task: make a new jet that would be able to defend the fleet from enemy aircraft. The simple part wasn't so simple, of course, because they wanted a real fighter this time that could outperform the F-14 Tomcat and even F-18s, which wasn't an easy task at all. And did I mention that this new fighter jet also had to be VTOL capable, meaning it could take off vertically, and also fly supersonic? Yeah, the stakes were high, but Yakolev was sure that this was their time to shine. The first issue with this design was the most obvious one. How the heck do you create a supersonic aircraft capable of vertical landing? Yakolev himself decided to go all in with this project and put the very best engineers on development and a study of feasibility of this design so they could then create an aircraft capable of hitting all the right spots with both the government and the Navy. You have to remember, by this point in the story, Yakolev had seen what had happened to Sukhoi and the other aerospace manufacturers in Russia when it came to politics. They knew that the case study was most likely to change at a whim, and they wanted to be prepared as possible. The most interesting part of this new design was the engine, or better yet, engines. The first concepts called for a single engine with a flat thrust vectoring nozzle, similar to what Boeing did on the X-32 down the line, but they scrapped that and decided to go for a much more complicated but also more rewarding system. Now bear with me because this is going to go a little deep dive into engineering. The main engine was the Soyuz R-79B300 afterburning turbofan that had an extremely interesting thrust vectoring nozzle. The issue here was how to rotate the nozzle downwards and then back up whilst performing a landing on a deck, and to do it gradually so the pilot wouldn't lose control and the lift engines could provide enough power to have it hover in place over a rolling deck. You can see here that the engineers from the Soyuz Bureau solved this by creating a rotating nozzle segment, which by rotating in the opposite direction completely changed the flow, and this is exactly how the F-35's Pratt & Whitney F135 engine works today. But more on that Lockheed connection later. The other engineering problem that they had to solve was the lift engines. They wanted to use just one lift engine separately from the main one, but if that engine failed at any point during the landing, the plane would crash and cause chaos on deck. So instead, they opted for two RD-41 engines, which would provide enough power for hovering. This system was also very good because the lift engines would take cold air from the top of the aircraft and not the hot air, which would lead to overheating, which is another problem that the Boeing X-32 had a few decades later. With this design, although very complicated, proved to be very good and gave the Yak-41 great performance in flight. Unfortunately, it was downhill from here. Initially, Yakolev was granted funding for 4 prototypes, and the idea was to have the aircraft in serial production by the end of the 1980s. However, the death of the defense minister, Ustinov, in 1984, and Yakolev's retirement, the program slowed down. They were also waiting for the engine, which was supposed to be ready by the end of 1984. So instead of having a pre-serial production aircraft, they only had their first flight of the Yak-41 by 1987, with a plan for serial production by the early 90s. Flash forward to 1991, and there was a great success with the jet performing its first takeoffs and landings on a carrier deck. But this news probably would have been at the back of the local newspaper because the Soviet Union fell apart. The economic shock of this development put an end to many prospective projects throughout the Soviet military, but the Yakolev Bureau was still clinging to their dream and decided to continue on their own dime testing of the last 2 flying prototypes before going for state trials. You're probably asking yourself now, why am I saying Yak-41 when the title of this video says Yak-141? Well, there's an interesting piece of trivia behind that. A couple years back during flight testing, 12 world records were set, but the Soviets wanted to keep the aircraft secret. So instead of its real designation, they called it the Yak-141, and it also just became that in the West. It was initially designed as a naval fighter jet. During development phase, the requirements were changed, no surprise there of course, and now the Navy wanted a multi-role aircraft instead, capable of also carrying anti-ship and anti-radar missiles like the Kh-31. Air-to-air missiles would have been from the standard Russian arsenal, such as the R-73s for close and the R-27 for mid to long range, along with the brand new R-77s, superior to their older counterparts. It would also carry 2 external fuel tanks that could be placed underneath the wings and give it an extended range. It's also interesting to note that the Yak-141 was built using composite materials, some 25%, which was a new technology for the Soviets and Russians at the time. The radar would have been a pulse Doppler one, and maybe even powerful ones initially developed for the MiG-31s in the late 70s. All in all, this would have been one very capable naval jet and a very nice variety of the newest Russian missiles, able to perform a great variety of tasks both against air and ground targets. In late 1991, test pilot Yakolev made a hard landing on the deck of the aircraft carrier, and the prototype fighter jet caught on fire. Although he ejected in time and survived, this would actually prove to be the nail in the coffin for the project, at least on paper, because the reality was there was simply not enough funds for serial production. The entire team were all working on borrowed time, and they probably knew that by the end of the development cycle that they could only fulfill their dream of making this thing actually fly. Funding was cut and production plans abandoned, but Yakolev Bureau found one unlikely and interesting partner to shift all its new technology. It was none other than Lockheed, who provided further funding, most likely in exchange for valuable R&D information and experiences with the platform, so the Yak-141 was presented to the public at the Farnborough Airshow in 1992. By 1993, it was shown one last time at the Moscow Airshow, and both prototypes were sent over to the museums where they stand to this day. Lockheed, with its X-35 and down the line the F-35, ended up using many of Yakolev's solutions for their aircraft, although further developed and much superior technologically. It was probably one of the most interesting and frankly unexpected cooperations in aviation history. Thank you so much for watching, I hope you enjoyed, and please do check out our Patreon for extra content and early releases. And don't forget to smash that subscribe button like the Pentagon smashed taxpayers' dollars in the JTF program. And give this video a like so the algorithm loves us, and leave the comment section on fire. Until the next one. In 1967, the Soviet Union organized the largest military exercise the world had ever seen to that day. with over 180,000 troops and hundreds of aircraft participating. However, the role of a close air support aircraft, essential for then modern infantry tactics, fell down to fighters. This was a big and embarrassing problem for the superpower. A year later, the Soviets released a report calling for a new attack aircraft to fill in that gap. It would be called the Su-25. After developing nuclear weaponry, military doctrine in the Soviet Union started to change. Attack aircraft were not needed anymore, it was all about the speed and having a fleet of bombers carrying weapons to end the world. However, very soon they would understand that this doesn't work if there's a conventional war, one without the use of these nuclear weapons. After the large-scale exercises in Ukraine in 1967, where the role of close air support was performed by Su-7s and MiG-21s, they realized that this wasn't going to work, and soon that they would need a dedicated attack aircraft. Their previous aircraft, the Echelon 10s, were already obsolete. So Soviet engineers got to work designing the future of close air support. Unlike the other jets of the era, influenced by the whole supersonic hysteria, this new aircraft was to be subsonic. MiG-17s, which had also participated in the previous mentioned exercise, performed the close air support role far better than the supersonic aircraft. They weren't too fast, and pilots had time to aim properly and handle the aircraft easily. And it's exactly this that two engineers at Sukhoi took notice and started developing new design ideas in their spare time. Instead of trying to hedgehog their way through the bureaucracy of the Soviet Union, they decided to make the idea themselves and then use the help of young engineers and students to have together a complete proposal, and only then propose it to Sukhoi himself. And that's exactly what they did. Sukhoi was surprised and interested in the idea, and quickly it was forwarded to the commander of the Soviet Air Force and his higher-ups. This spurred enough interest in the ministry that they decided to put together a new design competition for this attack aircraft. Echelon, Yakolev, Mikoyan, and Sukhoi were to participate, but thanks to the audacity of these engineers, they had an ace up their sleeve. Because they had already developed the design itself, they moved on to the next phase of tunnel testing and built a full-size mock-up. And you can guess that when it came to the actual presentation, when Sukhoi wheeled in their full-size mock-up into the auditorium, the other paper projects were dismissed immediately. The prototype was green-lit, and the game was on. By 1975, the first prototype of the Su-25, called the T8 at the time, had its first flight, and many more to follow. It proved to be much superior to its main competitor, the Echelon 102, but the most interesting part here is that the test pilot who flew the Su-25 prototype was none other than Vladimir Echelon, son of Sergei, the founder of the Echelon Bureau. So talk about a betrayal close to the heart. He would actually spend most of his career as a test pilot for Sukhoi and even tested jets like the T4, a story about which you can check out right here on the channel. But what about the design of the Su-25 that made it so darn special? This jet has a traditional aerodynamical design with shoulder-mounted wings. There's nothing too interesting on the surface, but it's what's under the hood that actually makes the difference. Often described as the flying tank, the Su-25 is one of the most armoured aircraft even flying to this day. The cockpit is inside the titanium tub with an additional thick steel head protection. Furthermore, the underside is additionally protected with plates on the front landing gear doors. To push all this weight around, the aircraft would have two Tupolev R95SH engines, providing the Su-25 with a maximum speed of 975 kilometers per hour. These two engines are actually separated on the fuselage and made to work completely autonomously. So in case one is damaged or destroyed, the pilot actually has control over the aircraft and can still land safely, which has often been the case throughout the years, and the latest being in the war in Ukraine. One of the engines had an additional titanium plates, and if you're asking why only one, well, the answer is rather simple. It would be too heavy to add armor to both of the engines, so if the armored one gets hit, it will survive, and if the other one gets hit, well, we still have the other engine working anyway. Soviet practicality at its finest. During the development phase, hundreds of tests were made with different caliber weapons firing at the Su-25, and one of them even featured dropping warheads into a working engine to check the effects of a manpad hit in flight. With all the fuel tanks filled with a sponge-like material to prevent fire being spread easily if the plane is hit, and also stop fuel from leaking, this jet seriously has redundancy up its exhaust pipe. And speaking of fuel, one of the craziest things about this aircraft is that it can run on diesel. The Soviets really wanted an aircraft that could be used anywhere at any time. And during the development phase, the main requirements were that this jet be able to take off and land from almost any flat patch of surface, be it a road, a runway, or a field. Additionally, it also had to be made out of non-deficiency materials, easy to control and suitable for pilots with less skill, and obviously, very easy to repair. It's basically an AK-47 with wings. The tip of both the wingtips also house air brakes, which help the pilot decrease the speed during an attack run and to land on a very short runway. But this jet is not all just armor, there's also firepower. Unlike the equivalent A-10 in its famous Brrr machine, the Su-25 only has double 30mm autocannons below its nose. However, there is an option of mounting an additional two 23mm autocannons on both wings, which would total to a pretty insane amount of lead being sent down the range. In total, there are 10 hardpoints for different kinds of weaponry, 5 on each wing, with a total ordnance capacity of 4.4 tons. A variety of bombs from 100 to 500 kilogram ones, unguided and guided missiles, and fuel tanks can be carried on these hardpoints, along with R-60 and R-73 missiles, giving this plane at least a chance in air-to-air combat. So what did the Russians even end up calling this colossal killing machine? It was given the name Grach. Grach, translated as Rook, as the Russians call it, or as NATO calls it, the Frogfoot, comes in two base variants, a single-seater and twin-seater with UB designation made for training. However, in the late 80s, an interesting variant called the Su-25T and TM were developed. This aircraft was based on the two-seater design, but one pilot behind controls, and was specialized in tank hunting. New optical systems and new missiles were tested by the end of the Afghanistan war with great success. The pilot only had to designate the target, and the onboard systems would track the target while moving, and the missile could be fired and forgotten. Apart from that, the TM variant, also sometimes called the Su-39, could carry TV and laser guided missiles and guided bombs. This promising upgrade never came to life, however, and stayed in limited experimental phase, because the new Russian Air Force deemed it too sophisticated and expensive and opted for a Su-25 SM modernization down the line. After entering service in the USSR, it was used extensively during the Afghanistan War and then used in the Chechen Wars during the 90s. It saw combat during the Iran-Iraq War too, with Iraqis flying numerous sorties daily. In Europe, it was also used during insurgency in Macedonia and of course during the current war in Ukraine on both Ukrainian and Russian sides. It proved time and time again to be quite versatile and forgiving for the pilots, saving their lives on numerous occasions because of its rugged design. On the other hand, with weaponry being pretty outdated for the modern era of fighting, both Ukrainian and Russian air forces have suffered heavy losses of this platform during the war, because traditional attack aircraft in contested airspace is definitely not a good idea. Something that the US Air Force learned during the Gulf War with their significant A-10 losses in the starting phase. With production lines being closed in Russia in 2017, a question arises: is there even a future for the Su-25? Perhaps there will be another deep modification like the Su-39 or a change in doctrine and weaponry. Whatever happens, we can be sure that it will stay in service for at least some time, just like its brother from the US, the A-10. Let me know your opinion down below and what you would like to see next here on the channel at Found and Explained. And if you haven't subscribed already, click that subscribe button because we really need some more people to boost us up to that goal of 1 million subscribers. See you next time. A long time ago in a country far, far away. No, this is not an X-Wing fighter from the Soviet Star Wars, but rather a story of ambition and young engineers daring to create something completely different. A tail-sitter aircraft concept patented by none other than Tesla was experimented on by both Nazi Germany and the US, with the Convair Pogo being the most prominent one. The Soviet attempt at this idea was probably the best looking one though. A MiG-25 meets Star Wars type of aircraft powered by two engines that could take off and land to any small patch of flat surface. It might have been the perfect aircraft for the Soviet Navy and the Air Force alike. This is the story of one of the craziest Soviet designs ever imagined, the real-life X-Wing, the Sukhoi Shkval. Design and the idea of a tail-sitter aircraft originates way back to 1928 when Nikola Tesla patented the concept. Yes, that Tesla. As usual, the Nazis saw the crazy idea and had to try and make it for their equally insane Führer, and the Focke-Wulf Triebflügel was born. Let me know if you'd like to see a video on that design in the future. We move forward to 1950s, and it was actually the French who wanted to try their best at the daring design, with local engine manufacturer pushing the idea to prototype phase with their C-450 Colopter. Convair was next to create an actual flying prototype of a tail-sitter delta wing aircraft called the Pogo, which I've already covered and you can see it right here on the channel. And now we have arrived to the point in our time where our story starts. Moscow, 1960. The 60s were a crazy period for Soviet aviation industry. With Stalin's death and Khrushchev's missile obsession, almost every bureau in the USSR was working on daring new designs that would accommodate new military aviation doctrine to get those sweet government funds. And then there were the young or inexperienced engineers fresh out of college who were not able to participate in these huge projects because of the time restraints and the importance of success, who ended up just sitting around. One of them was Roland Martirosov, Sukhoi's bureau engineer, who decided to do something about it and gathered a team of colleagues to work on a completely new design in their spare time. Their work started by using the fuselage similar to one of the Su-15 interceptors, with large canards to help with steering and maneuverability mounted on top of D-shaped intakes. However, this design didn't work out and they switched to an intake design similar to one on the MiG-25. Fuselage would have 4 wings positioned in an X shape with integrated fuel tanks mounted at the end of each of the wings and some sort of landing gear or shock absorbers at the bottom. Each of the wings would have had a rudder that would actually work as both a rudder and an aileron during the flight and help the pilot steer the aircraft. Additional canards were mounted in the front of the air intakes to help with the stability during the flight, something that the Convair Pogo lacked. The aircraft would have been powered by 2 engines, which would have provided enough power for vertical takeoff and flight with such an unorthodox design. After creating several scale models and completing wind tunnel tests, the team of young engineers felt that they were ready to actually present this concept to the main man himself, Pavel Sukhoi. When he was first presented with the idea, Sukhoi was hesitant. He clearly understood the situation in the country and how the budget was overstretched, with different bureaus developing various new planes and helicopters, and it would be very hard to have government funds diverted to such an ambitious project. But he was clearly happy with the initiative and the success of the project so far, so he decided to approve the project for further development and help the young team in their struggle. Specialists from the Ilyushin Bureau also reviewed and gave positive feedback for the ideas, and some funds were required to be pumped into further development of the project. He advised them, however, to go under the radar and continue to work on their own as much as they could before presenting the aircraft to the Soviet Union. With newly received funds and support from Sukhoi himself, the team pushed forward. In only 6 months, they built a full-size mock-up, which included a rotating seat for the pilot so he could have better visibility, whilst the steering controls were actually moved to the sides of the cockpit, which was very unusual and innovative for the Soviet aircraft at the time. In a final seal of approval, the team actually brought in Soviet Union test pilots to look over the cockpit and get a general feel to how everything was laid out. It seemed the team were finally ready to present it to the government. In 1963, the team presented the aircraft to the Council of Ministry of Aviation. After a very long and hard defense of the project before the council, they managed to get praise for the design and acknowledgement for their work. But after a long pause, the council ultimately rejected the idea. You see, to understand why this innovative concept was not developed, you also need to understand the current political climate of the USSR at the time. The USSR itself was still reeling from the political turmoil after the Cuban Missile Crisis. Tensions were slowly rising between the USSR and China, and politics smothered the birth of new aviation projects all around the country. Such a radical, X-wing-like fighter never even stood a chance. The team received many awards for their innovations, and many of the inventions that they created during the development of the aircraft were used in future designs. But this wasn't actually the end for the team. Marty Rosov went on to become the chief designer of the Sukhoi Bureau, as well as the director of the Su-34 program, and he left his legacy in the skies of Russia for the years to come before passing away in 2020. One of the other team members, Vladimir Babak, became the director of the legendary Su-25 program, and Bill Nov became the vice chief constructor, and others went on to become top brass of the Bureau during the Cold War. So whilst this project was a failure by itself, it helped skyrocket the careers of a young, ambitious team who would all go on to become legends in their own right. Just like this very humble, Star Wars-like fighter that they created in their youth. High above the Atlantic, a new terror has emerged. A Soviet supersonic bomber with a special purpose: to hunt and destroy US aircraft carriers. In the 1960s, the Russians developed in secret a state-of-the-art bomber that was unlike the West, or frankly, the world, had ever seen. The Sukhoi Bureau might have been well known for its fighter and attack aircraft, but this new bomber could have been a game changer for the USSR and may have even changed the ultimate outcome of the Cold War. So join me today to learn about the Soviet engineering and the story behind the Soviet Valkyrie. This is the Sukhoi T4 Sotka. In the 1960s, the Cold War was playing out in a worldwide game of spy versus spy. These espionage missions, much like James Bond, would bring over secrets to each side, some of which were plain terrifying. For the Soviets, one unsettling breakfast meeting was interrupted by the news of a new US supersonic bomber that could outdo anything they could muster. The XB-70. Scrambling to defend the communist utopia that they were building, the Soviets launched two important programs to counter this new threat. One was to be the development of a brand new Mach 3 interceptor to take on the possible threat of American bombers. The other one was a supersonic bomber program, much like its American counterpart, but with a much more sinister purpose. The first program eventually led to the MiG-25, but the other one is what we're covering today. Tupolev, Yakolev, and Sukhoi bureaus applied for this top-secret new bomber project, with the Tupolev being the logical choice because of the long tradition in bomber aviation. However, Pavel Sukhoi was always known to push for new technologies and concepts to meet the Soviet needs, and it so came to be that his bureau won the contract, and it was to be the first supersonic bomber in his portfolio. So already you know this was going to be completely different to anything the Soviets had built before. The goal of this project was clear: a speed of 3,200 km per hour, or Mach 3, as well as the ability to carry large anti-ship missiles. After all, this aircraft would have the US carrier fleet right in its crosshairs. And so work began on the new Izdalia 100 aircraft, nicknamed the Sotka. The T4 was very innovative for the Soviet Union, with around 600 patents directly linked to this project development, and in a minute you're going to see exactly why. You see, flying Mach 3, the same rules don't apply with ordinary aircraft. Aluminium simply couldn't handle the heat generated during flight, so instead it would need to be built out of titanium, a much stronger and much more resistant to heat metal to be used for most of the surfaces of this new bomber. And just like the fuselage of the legendary SR-71, it would be around 85% titanium all up. The T4 was also the first Russian fly-by-wire aircraft, which was a giant technological leap for the Soviet aviation, and experiences from the project helped a lot with the further development of the Su-27. Quick side note, if you're watching right now, I have a brand new space channel where I'm doing all sorts of crazy spacecraft that were never built. So perhaps click the link down in the description to check that out after this video. The T4 would only have a crew of two, a pilot and a weapons operator, and the design of the cockpit was very unusual. It would be very similar to a fighter jet cockpit, and the pilot would use a center stick instead of a yoke to control the aircraft. As with other large supersonic aircraft, the nose of the aircraft had a different position during the flight. While taking off or landing, the nose of the T4 would rotate downwards 12 degrees to allow the crew better visibility. In subsonic speeds, the nose would be rotated slightly upwards, and then when going supersonic, the nose would move further up and close in the cockpit completely. The pilot would fly on instruments from this point on, and two small windows were positioned on each side just for psychological comfort. The aircraft would be powered by 4 Kolosov RD-36 engines, which would be integrated inside of a gondola on the bottom of the fuselage. After all the ground testing and with 4 prototypes in development, it was time for the first flight. On August 22nd of 1972, the T4 took to the skies for the first time with test pilot Vladimir Ilyushin behind the controls. And yes, that's not a coincidence that he has the same last name of the famous engineer Sergei Ilyushin, because it was his son. Testing went on, however, there was a slight catch now appearing with the T4, and to better explain it, let's talk about its actual mission profile. You see, unlike the XB-70, the mission profile of the T4 was not to serve as a strategic bomber, rather specialized as an anti-ship bomber. The Russians were already developing strategic ICBMs for the end of the world scenario and didn't need a way to fly nukes into enemy territory. Rather, it was about leveling the playing field in a conventional war. The US Navy, unlike the Soviet one, was centered around carrier battle groups, and eliminating them would be cutting the head off a snake in a conventional war. This was to be achieved with the new Kh-45 hypersonic missiles. And yes, you heard that right, hypersonic in the 1970s. These were 4.5-ton missiles flying over Mach 5 with the option of nuclear or high explosive warhead, which were made specifically to sink US carriers or totally obliterate the entire battle group if going nuclear. The T4 would simply shoot and forget, as trying to defend yourselves against this weapon back in the 60s or 70s was almost impossible. So with everything seemingly perfect with this aircraft, what happened? The main issue with the T4 actually lies in its serial production phase. The only factory in the USSR that had the capability to build the Sotka was the Kazan aviation plant, but they were already building the Tu-22 at the time. With production problems with this latter jet, the USSR decided to scrap it and build the Sotka instead, which is where we get to the political infighting that was the demise of the project. But Tupolev had another idea and presented instead a different option, a modernization of the Tu-22 platform, a very deep one bearing the name the Tu-22M. The aircraft had a folding wing design which would allow for different mission scenarios. It was also better suited for low-level flight below the radar and therefore also better suited for a sneak attack on the carrier groups. And lastly, this was way cheaper than the T4, which is kind of a big thing for the Soviet economy at the time. So whilst there was never a Russian sneak attack on a US aircraft carrier, there was a Sukhoi sneak attack on Tupolev. The T4 took to the skies in January 1974 for the last time. Although a perfectly capable aircraft, it was like many other projects, a victim of budget cuts and fast-changing goals of the programs back during the Cold War. The only flying prototype is today located at the Central Air Force Museum in Moscow, standing right next to its supersonic brother that we've also covered on this channel, the M50, which ironically suffered the exact same fate. Sukhoi would not take this blow sitting down and would not give up on its supersonic bomber ambitions. Another opportunity opened up in the 70s, this time for a new strategic bomber of the Soviet Union, and Sukhoi applied with a new T4M design. This design implemented the variable geometry wings, which the government preferred, and put it up in competition with Tupolev and Messerschmitt. Spurred on by the betrayal in the past, Sukhoi went one step further and created something truly jaw-dropping, called the T4MS, or Izdalia 200. This was to be the first true stealth bomber in the world, and you can totally bet that we're going to do a whole video about it. Sorry to be a tease, but if you want to see this video, don't forget to subscribe or jump down in the comments and tell me how mad you are. Thanks so much for watching, and I hope you like this video. There's always much more cooking up in the Found and Explained kitchen. Yeah, boy. So please do hit that subscribe button, and I'll see you in the next one. Meet the Ultimate Bomber, a secret Soviet project from the late 50s that could have been the fastest military aircraft ever built, so fast that even the SR-71 couldn't catch it. Flying at hypersonic speed, this plane would have been unstoppable and could bring destruction to any Western city without them even realizing it, or blow apart an entire US carrier group before it even appeared on radar. Was this Russian design something completely crazy, or a feasible design that would have changed the world forever? Today we're going over Mach 5 with the DSBLK bomber. This week on my other channel, I have a video about the Nazi Sun Gun, a super weapon that the Nazis designed to evaporate New York. Check it out after this video, link down below. Let's face it, the late 50s and 60s were probably the coolest period in Cold War aviation history. Engineers on both sides of the Iron Curtain were being given carte blanche to create the ultimate weapons which could carry nuclear bombs to the targets on the other side. These bomber designs would bring both tactical and political advantage in any potential conflicts or proxy wars between America and the USSR. But there was one major problem with many of these bomber projects. Interceptors. Both the West and the East were in a constant game of rock, paper, scissors, each trying to develop a faster bomber and in turn a faster interceptor to beat it. The United States would eventually turn their SR-71 into an interceptor called the YF-12, the fastest of its kind, but it would still struggle to catch up with what the Soviets were making. A nuclear bomber that could fly as fast as the hypersonic nuclear missiles it carried. Unlike many of the other Soviet projects which you probably heard about so far on this channel, this one had a much weirder origin. It was started by the Leningrad Military Aviation Engineer Academy and led by none other than Alexander Moskalyov, as opposed to the bigger engineering firms famous for aircraft such as MiG or Sukhoi. Moskalyov was an interesting figure, an aerospace engineer who designed his first aircraft when he was only 26, and his first flying prototype when he was 29, truly an engineering prodigy. By his 40s, he was a prominent aerospace engineer and had started working on a new concept for a supersonic seaplane bomber, some of which that you can see here, and they're quite frankly ludicrous. Various different shapes were used, from the duck design to the tailless and of course the flying wing. And it's this last design that he thought that held the most potential. Hearing of the constant one-upping between the home Soviet bureaus and the capitalist Americans, he thought it was time to end the fight of the interceptors once and for all. And thus the design of the DSBLK was born. But it was also the wrong place at the wrong time. The DSBLK stands for Long Range Strategic Bomber Flying Wing, and was a concept for a new futuristic aircraft which would allow the Soviets to have a complete domination over US air defenses, one that puts speed above all else. First of all, Moskalyov was going for Mach 2 up to Mach 4 maximum speed. Let me remind you that the SR-71 wasn't even built at this time, and even then there would have been a fighter variant like the YF-12 concept to counter this new Soviet threat. So talk about planning ahead. But this wasn't the end of his mad dash for unlimited speed. Combined ramjets and afterburning turbojet engine options were also explored, which would have pushed the maximum speed beyond Mach 4. We're talking hypersonic here. These speeds would have been achieved at an extremely high altitude, over 30 kilometers or 100,000 feet. And the expected range of this aircraft was around 16
15,000 kilometers. This would allow the DSBLK to strike almost anywhere in the world, depending on where it takes off from within the USSR. The fuselage of the aircraft would have been blended with the wing, hence the flying wing part of the name, and this would allow for minimal drag during flight and a maximum payload capacity for combat. But I'll get to its insane weapons in a minute. But you're probably wondering to yourself, how would they even construct such an aircraft? One word: titanium. Titanium was chosen as the material of choice as it was able to handle extreme speeds, and this beast was to be powered by 6 engines in total, separated by pairs of 3 in 2 gondolas. That construction material wouldn't be a problem to acquire for the Soviets, because unlike the SR-71, which had to use shell companies to get it, the USSR actually was the main producer of the material at the time. And boy, this thing was massive, 50 meters in length and with a 37-meter wingspan. Here you can see it against both the B-2 as the largest flying wing aircraft and the Tu-160 as the largest bomber in the world for comparison. On board, it would have a crew of 3 to 4 situated in 2 different compartments. Likely they would have the role of 2 pilots and 1 to 2 weapon officers or navigators. But buckle in, because now we're going to talk about weapons. The size of the aircraft and its powerful engines would allow for anywhere between 15 to 20 tons of ordnance. Compare again with the B-2's 18 to 23 tons, this was quite impressive. The standard payload would either be nuclear or extremely large FUB 5000 bombs. But here's the interesting part. Do you remember those Ha-45 hypersonic missiles that were being developed for the T4 Sotka not far into the future? Well, they surely would have been adopted by the DSBLK, which would also make this aircraft into the perfect aircraft carrier killer. And with a nuclear option on board the Ha-45s, that would mean they could annihilate a whole US carrier group in one go. There would be no defense against it. But we're not done yet. Speaking of defense, you might have also noticed these small turrets scattered over its surface. These remote controlled turrets, 2 of which on the top and 2 on the bottom, had 1,200 rounds each. The jet could also be fitted with air-to-air missiles for an added layer of security against anybody who tried to sneak up on it. Seriously, this aircraft really was overkill, and there was even talk of an electronic warfare version and a spy version, just like the SR-71. It could fly as fast as its missiles, drop out of a high altitude, and be almost undetectable, all before the SR-71 was a twinkle in the eyes of the Lockheed Skunk Works. Truly horrible stuff. So the big question is, why did we never see this plane that was so clearly ahead of everything in the world? In the late 1950s, it was also the start of the space race, and the Soviets, with their intention to make an ICBM, got a great head start with the creation of the R-7 Semyorka. This was also the nail in the coffin for many prospective supersonic bomber projects throughout the USSR. While in the early 1960s, the project got the green light to move forward to wind tunnel tests, it was abruptly cancelled only 6 months later. There was simply no more need for a super or even hypersonic bomber if you could simply launch an ICBM and hit the target on the other side of the globe. Moskolyov was working with the Zagi Institute and other important institutions within the USSR on this project, but they simply never got the funding to get into prototype phase, even though the concept received high praises from officials and was actually thought to be incredibly feasible. It was both futuristic and also outdated at the same time because nuclear warfare was changed forever. Some of the findings made of this project were eventually used down the line in the construction of new Soviet bombers, but it's interesting to see how the US's X-47B design resembles the DSBLK in its flying wing configuration. What a coincidence.
Sonic boom as a weapon. In 1969, the USSR led a small yet potentially devastating conflict in the Far East with its communist ally, China. Soviet high command came up with the idea of a completely new type of weapon, an aircraft that could kill without any munitions at all and leave no contamination to the area where it strikes. The M25 was to be the first and only aircraft designed to use its sonic boom to devastate enemy troops in an open terrain battlefield. But was this the real background of the story, and why did the project never come to life? Put on some headphones as we investigate the incredibly loud M25 Hell Reaper. In the late 50s and early 60s, after Stalin's death, his obsession with aircraft was quickly changed in the military circles of the USSR. Strategic bombers were a thing of the past, and a new designation appeared: strategic missile carriers. Khrushchev's new obsession with ICBMs and rocket technology was paving a new way of conflict. A whole new world of alternatives and options opened up, and top-ranking Soviet engineers and constructors started working on these new ideas. And one of these was completely off the charts. Not much was known about this project up until recently, when some of the top-secret files were declassified, and when one of the chief engineers of the Masishev Bureau, Stanislav Smirnov, gave the insight to what was really happening behind the veil of secrets back in the late 60s. As his story states in the article published by the magazine Wings of the Motherland in 2017, it actually wasn't the Sino-Soviet conflict that created the idea and need of such a weapon, but rather the idea was already there a year before the conflict in 1968. Vladimir Vasilievich Struminsky, the director of the Institute of Theoretical and Applied Mechanics, started playing with the idea of creating a completely new weapon that could deal damage on a large scale by the end of 1968. Initial tests with this nugget of an idea were performed at the Lipetsk Air Base with MiG-21s to see how much power a sonic boom shockwave could actually create. And needless to say, the results were promising. Struminsky knew that the MiG-21 simply could not create a shockwave large enough to deal serious damage, rather just break glass and burst some eardrums, so that's where the story of the M25 starts, with a low rumble. He decided to go to a meeting to see a certain gentleman that could have changed the history of aviation and warfare in general. Vladimir Mikhailovich Masishev, the same guy responsible for all kinds of daring and futuristic aircraft designed throughout the Cold War. According to international standards, overflight at sonic boom speeds is not considered an opening of fire and is not a reason to unleash a war. This is the whole philosophy behind the project. After joining forces and ideas, they realized that they would need a completely new airframe with at least 4 engines to create a special type of shockwave that was going to lay decimation to the enemy. A simple name was given to a new top-secret project, Theme 25. The reason that they had to return to the drawing board was because of normal aircraft design. A typical plane wants as little drag as possible to preserve fuel. Low drag also means a lower sonic boom. Thus, this new design would need to be radical and fly in the face of engineers everywhere. This contender would weigh in at 110 tons, 30 meters long, and have a wingspan of 25 meters, giving it the appearance and aerodynamics of a flying brick. Flat surfaces would replace round cross-sections, and there would be two tails either side of the rear. To push through the air at speeds needed to go supersonic, the plane would need 4 vast engines mounted above the fuselage, engines which would be ungodly powerful and guzzle fuel. Other alternative considerations were considered, such as having the engines under the wingtips, and I can't believe I'm saying this on a plane video, increase the amount of drag. The shear forces and heat would require an experimental material for the plane itself not to tear apart in flight. And there would be a single pilot situated at the front of the plane riding the sonic boom like a surfer riding a record-breaking tsunami. Under the bottom of the plane there would be a special fuselage protrusion described simply as a ledge. It would extend when the plane was lining up for attack and increase the drag by up to 60%. Upon approaching its target, the plane would fly low to the ground, mere meters at Mach 1.4. It would deploy its ledge and wreak havoc. The final result, a sonic boom shockwave that would reach up to 6 psi, enough to collapse buildings, suffocate tanks, and burst heads. Gruesome stuff indeed. Gruesome stuff on paper, however. Whilst this aircraft's brochure has all the bells and whistles needed to secure funding and to impress the West, there were several major flaws.
The first was those supersonic engines. Whilst they had engines that could push an aircraft to those speeds, they weren't suitable for the project.
Whilst the Russians did have impressive engines for the time, such as the considered AL-21F, they didn't make the grade. The team was looking for an engine design that could punch the plane of this scale beyond Mach 1.4, but the best that they could do was Mach 1.15. The thought was given for the plane to be equipped with rockets for its attack run to get it over the line, but this would not only increase the weight and drag, but add to the heat generated. Plus, you can imagine all of the considerations that would be required for adding rockets to an already extreme plane. Which ties into the second problem. It was that this would be an extremely hard and dangerous aircraft for pilots to fly, especially to fly supersonic at such low altitudes. The plane itself could only really be deployed over perfectly flat terrain, or some kind of autopilot would need to be developed to compensate for any bumps in the terrain, which you would expect in a real-world scenario. So to put it bluntly, this plane would only really be effective in the plains of Nebraska. Having no engine suitable was a major roadblock for the team, and it led to other complications with the design, requiring more money and resources to overcome. There was also the nagging Pandora's box that the creators didn't actually want to open. Would a weapon that could kill on such scale even be ethical to develop? What if it was used against defenseless civilians? Ultimately, these factors led to the cancellation of the program, with it only reaching as far as wind tunnel tests. By this point in the story, the project had gained quite the reputation within the party, one that was seemingly becoming less and less feasible to realize. With the additional doubt that this sonic boom weapon would work, the government decided to pull the plug in 1972, the M25 to never return, with ironic silence falling over the project. The final question is, would this plane have even worked had it been built? While the science was thought to be completely understood back in the late 60s, they were hopelessly naive. Today we know that sonic booms are far more complex, and using it as a weapon is highly unpractical. In 2019, NASA conducted the first supersonic flight formation test flights to see how the waves interact with one another and how damaging it can be. The result was that the data was far more complicated than anyone could imagine. Had the planes flown with destructive intent, it would have been absolute, giving heavy weight to those ethical concerns. What's the point of a weapon that kills friend, foe, and even the innocent? But that wouldn't be the end of it. The Soviets did actually try to use sonic booms as a weapon a bit psychologically in Afghanistan, but we can't say for sure how exactly effective it was.
And it is well known that flybys with jets are often used as a deterrent and a psychological pressure, used effectively in the civil war in recent conflicts in Yugoslavia, Libya, and Ukraine.
What could have been a truly scary and gruesome weapon stayed only in an old dusty archive marked with a top secret stamp, and was never seen the light of day, and maybe that's for the best. But remember, next time you're out on an open field and see a glint on the horizon, the Reaper might be watching, and coming for you low and faster than you could ever imagine. The 1970s was a decade of rebirth for Soviet strategic bomber aviation, and Sukhoi was the one to lead them to a glorious future. Until they were betrayed. This new aircraft would revolutionize the warfare of the late Cold War era and turn the tables back to the Soviets' favor, but it simply wasn't meant to be. Find out why as we explore the legendary story of the top secret Soviet T4 MS. The late 1960s marked the start of an era in bomber aviation. Bombers were not just bombers anymore. They were now carrying missiles capable of bringing destruction to virtually any point of the globe. After many promising projects were abandoned on both sides of the Iron Curtain, thanks to the development of ICBMs, it wasn't until the paradigm of the Cold War changed that we saw a renaissance for bomber aviation. The US started early with the B-1 development right after the XB-70 concept was abandoned, and the Soviets soon followed after abandoning their own M50 program. 3 competitors were in the game for a new strategic bomber for the Soviet force. Tupolev, with the pedigree of this type of aircraft, with its Project 160. Masachev with the M20, and the unexpected player in this branch of the Air Force, the Sukhoi with the T4 MS. Sukhoi entering the strategic bomber game was unusual, but their promising work on the T4 bomber aircraft carrier Hunter had put them in a good spot for this race. But this wouldn't be the Soviet Union without a list of kind of ridiculous requirements for this new aircraft. It had to have a top speed of Mach 3, up to 18,000 kilometer range whilst flying subsonic, and 13,000 kilometers when flying supersonic, and it could carry a casual 45 tons of ordnance. Sukhoi's design was based off the T4M, a modified T4 Sotka with a variable geometry wings, developed to accommodate requirements set for the T4 program, but it would soon prove to not be viable for this kind of project. They needed a new approach. The Soviets had been exploring the flying wing hybrid design for extreme speeds up to this point with aircraft concepts like the M25 or the DSBLK, and Sukhoi would base its new design all around this idea. The new aircraft, now called the T4 MS, with M standing for modernized and S for strategic, would have a very flat fuselage and a variable angle swept wings to accommodate both speed and range requirements in either supersonic or subsonic flight. And the engines were to be positioned in 2 gondolas, with the first prototype being the Kolsov RD-36, the same ones used on the T4, and the serial production jet receiving the new NK-101s. The nickname was derived from the weight of this beast. It would have 200 tons take-off weight when loaded with ordnance and fuel. This is comparable to the B-1, but with a higher payload capacity. The weapons consisted of 4 Kh-45 hypersonic missiles, which were also being developed for the T4, and the new Kh-2000 missiles. Of course, standard guided or unguided bombs configuration of up to 45 tons was a possibility, but this wasn't what the plane was built for. However, when building this plane, by 1974, the first issues started showing up. After testing this design in wind tunnels, the engineers came up with the problem of the center of gravity when this aircraft was loaded. This led to a new design with an elongated nose section and added horizontal stabilizers. New design had 3 crew members along with other stats staying pretty much the same. With fly-by-wire system developed for the T4 and implemented here, this jet was state-of-the-art, at least in theory, and it was time for the Soviet Union to make a big decision. When all 3 aircraft were presented in 1972 to the Ministry of Defense, General and former bomber pilot Vasily Reshnikov was mad. Tupolev's project specs were falsely exaggerated, and he said, "They're trying to sell us a commercial aeroplane, not a bomber." Masashev's design was sound, but the issue persisted with no production line capabilities and experience with serial production. One of the reasons apart from the engines which led to the end of the existing M50 project. So the last competitor, Sukhoi, with experience, a very promising concept, results from testing, and most of all, the know-how to actually pull off this project, was the obvious choice. This was all happening in 1972, the year that the T4 had its first flight and was still a promising aircraft for the future of the Soviet Air Force. But Sukhoi would come to bite off their own tail in the process. The Sukhoi Bureau was developing the Su-27 at the time, a direct answer to the new F-15 threat on the west, and the most potent fighter the Soviet Union had ever built. Along with this jet, the production lines were also occupied with the new Su-24 and a proposed Su-17 modification project. The Kazan aviation plant that they had operating at the time was at absolute full capacity, and stopping all those production lines to build a new supersonic bomber, the T4 and the T4MS, was not only insane and expensive, but also impossible, due to them producing a new generation of fighters at the exact same time for the Soviet Air Force. So the Chief of Staff of the Soviet Air Force, Kutakov, decided that Sukhoi was the winner of the contest and was about to be awarded, but all the documentation would be transferred over to Tupolev because they had the production capability for this type of project and a pedigree in bomber aviation, even though they had not won the contract. Tupolev, of course, had other plans. Instead of continuing the development of the T4MS, Tupolev insisted on pushing forward with the Project 160, and you can already guess where this goes. It seems that they were so bitter about losing face in that existing competition against Sukhoi that they decided to pump out their own aircraft instead. After redesigning the Sukhoi aircraft and meeting the modified set of requirements, this led to the birth of the world's largest bomber to this day, the Tu-160. It proved to be an amazing aircraft in the end, but the question persists. Would the T4MS be better and give the Soviets advantage in the Cold War? Luckily, we'll never know, and now we can just admire this crazy but beautiful design, another of the lost Soviet aircraft that never saw the light of day. Thank you so much for watching this video today, and be sure to check out the other Soviet projects that we have on the channel, like the M25, DSBLK, or the T4. I'll see you in the next video. It was July 9th, 1961, Soviet Air Force Day. Spectators were in awe as a completely new supersonic bomber flew over the crowd, escorted by 2 MiG-21s. Sleek design powered by 4 engines with a maximum speed of up to Mach 2, it was a sight to see. It was the first time that this new aircraft was ever presented to the public, but Western military analysts had been debating a nuclear-powered bomber. But the story behind the Bureau and the new aircraft project was a lot more complex than what was shown on the surface. This is the story of ambition, ingenuity, and politics. But most of all, it's the story of one of the best-looking aircraft ever made, the Myasishchev M50 Bounder. Our story begins in 1953, with the USSR receiving news from their spy network in America about the upcoming B-58 Hustler. A new supersonic bomber, relatively small in dimensions, but with the capacity to perform all the tasks needed for the time and deliver a nuclear payload right into the heart of Russia. It threatened the Soviet military, and the higher-ups ordered the development of a new bomber to keep pace with the West, a challenge in which the Missishev Bureau was up to. Initially, the Bureau started out with a composite bomber. Some of these sketches included a two-part aircraft, one operating as a launch platform, and a strike aircraft that would separate upon entering the mission area. There was also another design based off a float which would allow the plane to take off and land on water, and some versions that had anywhere from 6 to 10 engines. By 1955, all of these concepts proved, of course, to be very difficult to materialize, but the idea of crazy modifications to this airframe would be a running theme throughout its development. But more on that later. Requirements stated by the government needed the aircraft to have a speed of up to 2,000 kilometers per hour and a range of 12,000 kilometers, as well as the ability to carry a nuclear payload. After testing 39 different concepts with the final design, Missishev would come up with the final design of the M50 Bounder. The big question that remained was the position of the engines on the fuselage. The final decision went to the aerodynamically sound, but not structurally sound, placement, which we'll get to in a minute, with two pairs of engines, with one mounted on the wingtips and the other on underwing pylons. The sheer size and advanced requirements set for the aircraft presented many challenges for the engineers, and it took another 4 years to solve issues with structural stress calculations and materials needed for the aircraft. Initially, the Zubets Bureau was developing new turbojet engines for the M50, but development was so far behind schedule that in the end, they had to settle for the Doctrinian VD7 engine, which in total gave performance almost despite the final design worse than planned. Despite the final design failing to meet the requirements, only 10,000 kilometers of 12,000 kilometers proposed range, a prototype was approved and the M50 took to the skies in 1959. But was the aircraft doomed to fail from the first moment it took off from the ground? While the test pilots put the M50 through its first steps, the engineers got back to work ironing out the issues with the prototype design. This new version, literally called the M52, as in the second version, would fix many of the air quotes compromises the engineers needed to make. The M52 would be basically the M50, which ticked all of the needs and solved all of the issues with the original design. It was made to be a bit shorter in length, but with proper engines and the ability to carry large missiles, which would suit the new doctrine pushed by the government at the time. Again, after a lot of back and forth with the Ministry of Aviation, approval was given to create 5 prototypes in the late 1959, and the game was on for Russia's new bomber fleet. Now let's get back to the original M50. The first flight was successful, and the M50 even got a slight upgrade with its engines being tuned to provide even more thrust on takeoff. Unfortunately, this is the point of the story where politics took their hit at the project. Khrushchev's main direction for the future of the Soviet Air Force was missiles and not planes. Insane amounts of money were being diverted to space and rocket development programs, which would lead to nuclear between the US and US. Peak of the space race between the US and USSR. But on the receiving end of this decision were many prospective aviation projects and their bureaus that were left with empty wallets and empty hangars. Furthermore, another hit struck the Missishev Bureau. The Soviet government decided to close it down in 1961 and placed Vladimir Missishev as the director of the Central Aerohydrodynamic Institute. A prestigious position, but never what was really his dream, to see the M50 proudly bear those red stars on its wings through the clouds. So now we're back again to July 9th, 1961, and you're probably wondering how was the aircraft performing in an air show when the Bureau was already closed, and why the West was scared so much. Well, the decision was made to refit the prototype and make it ready for the air show as a show-off to the West. An ironic one indeed. After getting additional flight testing, it was ready, and on July 9th it was flying its first and last public presentation in all its glory before the eyes of spectators and the eyes of the world, only to never be seen in the air again. The M52 suffered the same fate, even though the prototype was nearly completed, because of one key thing that both prototypes missed: the engines. Zabet's 16-17 engines never arrived in time, and when the Bureau was closed, so was a whole series of projects. In the end, the design was sound, all of the structural issues were solved, and many of the new advanced solutions were created for steering and controlling this aircraft. Put an end to this project, and the politics that put an end to this project. Mr. Chef tried to revive the program in the late 60s, having his new position in mind, but with no success because the design was already obsolete and the Sukhoi was developing the new T4 bomber, which we'll talk about more in a future video. It might be interesting to mention that there were a couple more daring concepts made during the development of the Bounder, with a long and proud future planned for the series. The M56 and M57 were designs very similar to their future counterpart, the XB70. Although unlike the XB70, they never left the drawing board and scale model phase. And the craze regarding the nuclear bomber thing was actually justified, but they were just scared of the wrong aircraft. It was Tupolev who created an experimental aircraft for testing the said technology called the Tu-95 LAL. But the funny thing is that Messerschef was actually part of this project too and helped Tupolev in development. It's very likely why the wires got crossed and the West thought that the experimental and highly top secret M50 Bounder was the plane from their nightmares. A nuclear-powered, unmanned, supersonic strategic jet bomber. Sounds like pure science fiction, but not for the Soviets. This was an insane seaplane idea conceived and explored way back in the 1950s as part of the Communist Manifesto for world domination. All the best engineers of the Soviet Union joined together at the peak of aircraft development to create a dream of the atom-powered future to crush the hopes of the US military superiority. Hold on to your chair, as today we split the atom to explore the pinnacle of Soviet nuclear aviation. Oh, and don't forget that we have an online merch store. Every week, new items. FoundandExplained.shop. By bombarding the atom of uranium with a neutron, the atom splits and send additional neutrons around, which in turn hit more atoms, splitting them up too, creating a chain reaction and releasing kinetic energy in the form of heat in the process. This is a simplified explanation of nuclear fission, a discovery that would change mankind forever. Control the nuclear fission and you get a perfect source of energy, and if you don't control it, you get, well, the big mushroom. Now imagine having an almost infinite source of energy on a bomber. By the time the Soviets started working on nuclear-powered jet engines, the US was well ahead, having already developed actual test models of said technology. The power of the atom was so temptatious and promising that both governments decided to pour a lot of money and brains into exploring this new concept. The 50s also marked the beginning of the supersonic era, and both sides of the Iron Curtain were competing in building faster and sleeker bombers to carry deadly nuclear warheads to the other side. A game of cat and mouse of catastrophic proportions. So it was in 1955 that the Messerschmitt Bureau got the order from the Soviet government to design a new prospective bomber capable of supersonic flight using nuclear jet engines. Something so fast that even the Americans would blink and miss it. The Saturn Bureau was tasked with developing the said engines, and Tupolev had to test all of the safety and weight requirements for flying a nuclear reactor on board the aeroplane. The bar was set high and the game was on. Messerschmitt based its first design something pretty much that looks like an F-104, however there was no cockpit and the pilots would be seated in a lead capsule in the nose section and fly the plane using periscopes and cameras. Not exactly ideal, but the only way to avoid the radiation. Another design used the M50's airframe as its base, with the pilot being seated in the tail section and the main engine and reactor in the nose. Kind of an Uno reverse of a plane. However, not only was it that this was extremely hard to operate this aircraft from the closed capsule, but the capsule itself would weigh around 30% of the total weight. Add in a nuclear reactors with engines to that number, and the actual load capacity goes down drastically. It essentially becomes a giant paperweight. Meanwhile, at Tupolev, they modified a single Tu-95 airframe, now called the Tu-95 LAL, with the suffix standing for Flying Atomic Laboratory, which had that nuclear reactor but was not used to power the engines, just to test the shielding and stability in flight. With manned options being pretty much useless at this point, Messerschmitt started thinking outside of the box and proposed something even crazier. One might ask how exactly a nuclear-powered jet engine would work. Well, if you're not familiar with jet engines themselves, let's explain the engineering behind it first. In very simple terms, air is sucked in front of the engine and then compressed, and as the air compresses, it also gains heat. Now, this compressed air is mixed in with fuel and combusted. It's then pushed through the turbine, which uses its energy to power the compressor and blast out the back of the engine. Simple. Now, what if we use something else to heat the compressed air before pushing it out, something like a nuclear reactor? The Soviets developed two variants of this engine. The first one would house the reactor separately from the turbine shaft, and the other one would have a shaft placed in the axes of the reactor. They quickly gave up on the first concept because it would take up so much more space than the second, and unlike the Americans who tried to develop a variant which would not blast out the aerated air behind the jet, the Soviets didn't really care much about the countryside, so don't tell Greta Thunberg about this one. Anyways, this was just the tip of the iceberg regarding the problems that needed to be solved. With manned options being pretty much useless at this point, Messerschmitt started to think outside the box and proposed something even crazier. The project, dubbed PAS, or Prospective Nuclear Powered Aircraft, was internally called Project 60 in the Bureau, and hence why the final design got the designation M60M. And boy, was this a nuts jet. First, the Soviets removed the pilots. The M60M would have been an unmanned aircraft, or a drone if you prefer. By dropping the pilots, you would also drop some 10 to 20 tons of lead shielding around the cockpit from the aircraft and make room for more ordnance. The aircraft would then be fitted with weapons bays carrying nuclear bombs or even missiles with nuclear warheads. The range was also increased from a planned 15,000 kilometers to 25,000 kilometers. The drag was reduced significantly with the new design, and it was fitted with 4 engines, giving it insane power and an easily achievable speed of over Mach 3. Then there was also another issue. Any airfields where these aircrafts were based were potentially Chernobyls waiting to happen, because if anything went wrong at any moment during takeoff or landing, then you have 4 nuclear reactors melting down in your yard. But that's exactly why the M60M would be a seaplane fitted with retractable skis for landing and reducing the risk of a complete land-based disaster. However, one event happened in 1957 that made this whole fever dream of a project simply obsolete.
With the first successful flight of the R-7 rocket and further development of ICBMs, supersonic bombers, be it standard or nuclear powered, were simply not interesting. Why send a pilot on a risky mission in a multi-million-dollar jet if you can just launch a ballistic missile instead? You don't even care if the delivery vehicle survives the trip. And don't get me started on all the ways something could go wrong with an unmanned flying nuclear bomber in the 1950s with Soviet tech. Not to be disheartened, Tupolev tried making his own proposal of a plane called the Tu-119, which was to be powered by 4 nuclear-powered turboprop engines. And even though the Tu-95 LAL had over 30 successful flights, the 119 was never built. Antonov tried experimenting with anti-submarine aircraft, which would be nuclear-powered, and even made a flying laboratory based on the modified AN-22 airframe. However, by the late 1960s, all the projects were abandoned and the idea of a nuclear-powered aircraft was dead. The Americans tried with their Project Pluto, a nuclear ramjet engine for SLAM missiles, and there was even information about a nuclear-powered drone like the Global Hawk that could stay up in the air for months at a time, while Russia is said to be experimenting with similar concepts even today. Let me know if you would like a video on Project Pluto or any other nuclear-powered project. Thanks so much for watching, and don't forget to subscribe to the channel, and I'll see you in the next video. The Soviet Union has a problem. While they are surrounded by America and their allies, they themselves can't reach the continental USA. The Atlantic is too large, and any attempt to move an invasion across it, be it by sea or air, would be detected and destroyed. But what if there was another way? By using submarines. But not just any submarines, but insanely over-the-top science fiction level monsters that if built would dwarf even the largest machines ever built. These sea monsters could carry everything from aircraft, battalions of troops, and even tens of tanks at once. Undetectable and immune to naval blockade, this was to be the ace in the hole for winning the Cold War. And believe it or not, the Soviets even started construction of a fleet of them with plans to use them to capture Western air bases in the Arctic Circle by surprise, before an invasion of the North American coast. Let's dive deep into the nightmare of the West, the insane history of the USSR's giant amphibious assault submarines. This tale begins deep into the Second World War. The Soviet Union discovered that using submarines to shuttle weapons, supplies and special forces into besieged areas or behind enemy lines in World War II, specifically during the siege of Sevastopol, proved to be a game changer against the Nazis. The ability to keep the supply line hidden from surface weapons and operate with near secrecy gave an upper hand to the defenders, and in no small part turned the tide of war in their favour. Thus, in the spirit of victory in 1948, the USSR got serious on large submarines. The idea was that submarines could carry far more than just supplies for a bunkered down surrounded unit, but rather an actual force to defend or invade during times of war. This first project was dubbed Project 621. It was proposed as a landing ship transport submarine that could set down troops behind enemy lines. With some 5,950 tons of displacement, the underwater giant would have been one of the largest submarines of the day. The maximum surface speed was approximately 15 knots and 8.4 knots maximum underwater, with a range on the surface of around 6,000 miles. The Soviets would turn to steam gas turbines to be their power plant of choice, since in comparison with other options, this ensured the greatest submerged endurance range. Again, you've got to keep in mind this is before nuclear power was available. On its 2 vehicle decks, it was to carry a full infantry battalion of 745 troops, 10 T-35 tanks, 12 trucks, 12 towed cannons, and 3 catapult-launched LA-5 fighter aircraft for air cover. Yes, this was also technically an aircraft carrier submarine.
Now, I can see you already asking in the comments, how did they unload this force? Well, it acted just like a beach landing craft. The sub would approach the shoreline and come up unexpectedly, resting on the beach's bottom and filling the rear ballast tanks and tilting the front up. The troops and vehicles meanwhile would be unloaded over the bow ramp when the submarine breached on the surface. Talk about one heck of a surprise. Once unloaded, the sub would be much lighter and be able to refill with air into its tanks and then push off. But like all insane post-World War II ideas, there were two major flaws. The submarine didn't actually have enough room on board for the full infantry battalion to travel 6,000 miles. There was only one bunk bed for about every 4 people. Essentially hot bunking so hot that you could cook a dinner under the covers. And that exhaust system wasn't sufficient to have multiple machines active on the decks, especially during the vulnerable offloading period. You could imagine the fumes. So the USSR decided to go back to the drawing board and come up with something else, a submarine that would have the ability to travel through solid ice. The year is now 1952 and the race for the North is on. Both the USA and the USSR realized that the Arctic battlefield would be ruled by submarines, and the concept of an amphibious assault submarine would be the edge that the Soviets would have against those dastardly capitalists. Called the Podledno Transport, which is Russian for under-ice transport, Submarine Project 626 was started to deploy troops in the Arctic areas, as well as support air surveillance and communications in the Arctic basin. At 348 tons and 100 meters long, this sub had the capacity to carry 5 tanks, necessary fuel and ammunition, as well as 165 crack commandos and their supplies for missions in the polar regions. But let's crack this bad boy open and have a look inside. You'll notice that right away that the submarine is actually quite tall, and that it has a figure 8 cross-section of 2 main levels split into 2 compartments. Starting at the rear upper level, we have 2 torpedo tubes with 4 torpedoes, making it capable to hold its own in a limited engagement. Directly underneath was the engine room that had 2 2,000 horsepower engines connected to one propeller to give it a speed on the surface of 12 knots or underwater up to 8 knots. Moving forward, we also have a primary habitation and control room for mission operations, and then the main cargo lift. Yes, unlike the previous Project 621 with the forward ramp, this version would have a lift in the middle that could move the tanks and troops up to the front of the con tower vertically, so it didn't need to breach itself. And you're probably wondering why this design was chosen, because of its mission to operate in the ice. The idea was that the submarine could pop up anywhere at a moment's notice, surprising the Western forces. Its con tower would be heated to melt the ice up to 4 meters thick, and then the sub would surface only its top half, deploying troops and tanks, plus 2 paired P25 anti-aircraft guns right in the middle of an enemy force, which is just plain cool. At the front, we have the main cargo hold with the armor or troops, and underneath are the main batteries. Additionally, a self-propelled mobile pontoon was securely fastened into the superstructure aft of the main command deck. The Soviets believed that they could use this submarine to capture Allied airfields on the surface of the ice, which could then refuel Soviet bombers for further bombing missions to America. Now, there was also one issue with this concept: power. The current technology made it slow, and it was definitely fuel hungry. Luckily, a new power source had arrived on the scene: atomic. But you couldn't fit in a typical nuclear reactor into this small submarine.
Should we back off? Should we play it safe? Nah, you think let's make it bigger!
So they needed to go bigger. In August of 1967, the USSR began to work on their magnum opus, Project 717. This would be the ultimate strategic everything submarine, able to not only deploy forces anywhere in the globe, but to also create and deploy mines at a moment's notice, and to go head-to-head with the enemy fleets. It was redesigned as the jack of all trades. With a displacement of up to 11,000 tons, this submarine was to carry up to 20 amphibious tanks and BTR-60P armoured personnel carriers, as well as 470 troops, with the vehicles stored in a double-deck hulls contained to the both sides of the main hull, with all three having an outer shell, giving it a very unique cross-section. At the rear of the vessel, we also had the main reactors and engine room with plenty of storage for supplies for the invading force. Plus here there was also a special mine production facility that could build and deploy sea mines without surfacing to interrupt enemies' shipping. Moving forward, there was a living quarters and access to the twin cargo compartments. The con tower was also quite long, with AA cannons kept in sealable hermetical modules, and a special rescue chamber that could be used in the case of an emergency. But it's when we get to the front of the submarine that it gets even more insane. The vessel was designed to unload in the same way as the previous Project 621, with twin ramps on either side of the bow. There would be a special bow ballast in the middle that would allow it to make beach landings, as well as casually 6 torpedo tubes with 18 to 20 torpedoes. Oh, did I mention that it also had AA guns and surface-to-air missiles? Yes, this was a beast of a submarine, and it was just missing nuclear ICBMs. But this is possibly one of the most complex submarines ever designed, both in the East and West, and figuring out the engineering was a Herculean task in itself. The engineers built several 3D models that could be rearranged in their components, swapping them around to figure out the best configuration. The final model was also used in fluid dynamic tests, meaning that they had to pretty much make a mini version of this submarine. By March of 1972, the technical project was a wrap and construction was ready to begin. The plan was to create a series of 5 of these bad boys to have a mini fleet ready to challenge American dominance. But alas, the construction of submarine 717 never got the green light. The NSR, the one and only Soviet plant up for the task of building these colossal ships, was caught up in the Nuclear Polarity Agreement with the United States. This agreement limited the number of nuclear weapons or nuclear-powered military machines, including submarines, and thus the plant was under heavy scrutiny from the West. The Soviet Union decided to shift gears, focusing their limited nuclear allowance towards heavy missile submarines, such as the Typhoon, as a response to the US Trident program. And just like when we tried to build the submarines for Project 648 and 664, the spotlight shifted to strategic vehicles, leaving the dream of creating a massive amphibious transport submarine in the dust. While this was the end of the Soviet amphibious assault program, it wasn't the end of the idea. After all, what about the American attempts? While the US Navy dabbled in preliminary designs of submarine transports in the past, it never reached the scale of the ambitious Soviet design program. In the 1950s, a concept for a 10,000-ton submarine emerged, boasting dimensions of 220 meters long and a beam of 38 meters. This underwater behemoth was envisioned to accommodate 2,240 Marines, deploying them through amphibious flying platforms, which wasn't specified in exactly how they were propulsed. Not much is actually known about this program, although I'd love to do a video if someone can secure me the top secret documents. But remember at the start of the video how I mentioned that America ruled the air over the Atlantic Ocean and that it would stop any Soviet invasion? Well, when it came to submarines, they also had that in mind as well, and designed, believe it or not, multiple aircraft carrier submarines. And the best part of this news is that the video on it is already on the channel and you can go watch it right now. Thanks for watching. Whatever happened to land submarines? You know, the type of machines that go underground instead of underwater. What do you mean these things don't exist? you forgot what channel you're watching. That's right, on this episode of Found and Explained, we're going to be going underground into the history of subterranean warfare and how the Cold War's favorite bad guys developed an actual land submarine that was designed to wipe New York City off the map. And yes, this bad boy was nuclear powered. Meet the incredible land submarine, the Soviet battle mole, the Subterrain. Love aviation? Then come and check out our aviation news channel, Aviation Station. Every day, new videos. Now, I can hear you all writing in the comments. Technically, a submarine is specific for water, as it's in the name, marine, and therefore a land submarine would actually be called a subterrain. Or in Russian, a rough translation what they called it was underground boat. This is specifically a type of vehicle designed to navigate beneath the Earth's surface, like how a submarine traverses underwater. It would achieve this by either employing mechanical drilling methods or by utilizing a heat-based approach to melt its path forward, with the Russians investing in the first design and the Americans in the second. Despite being more popular in fiction before World War II, practical thermal designs and real-world examples of subterranes began to emerge during the latter half of the 20th century. After all, sometimes the truth is stranger than fiction. Our first real example was in the 1930s, with the earliest Soviet attempt at this concept being led by engineer Alexander Tupolev. And this is where the term underground boat originated. This unique vehicle was operated by a single person who relied on electrical cables dragged behind it for power. The idea was to venture deep underground, explore until it found an oil deposit, and then pull a pipeline back up to the surface. Unfortunately, this prototype could only manage a meager 12 meters before it broke down, leading to the abandonment of the project. But after World War II, Nikita Khrushchev got fascinated with developing unconventional systems. And they got this idea by, you guessed it, the Nazis. The Soviets had gotten hold of German blueprints for a subterranean, and even though it was never constructed, it was initially meant to transport a crew of 5 underneath the English Channel, tunnel right below a chosen target, and then plant a massive bomb. Whilst this idea was utterly impractical, Khrushchev revisited it in the 1960s with the introduction of nuclear reactors. The new plan involved tunneling to an American underground missile facility and command posts without detection, and then demolishing them from underneath. This concept became known as the Battle Mole. It had a crew of 5, 15 armed soldiers in transport, and a ton of explosives. It would use a standard cutting head powered by a nuclear reactor's electricity. Its speed was estimated to be around 7 kilometers per hour, which was about as fast as a brisk walk. The testing phase, which is believed to have taken place in 1964, although this is a big rumor, was a huge success. The giant machine was apparently vanishing into the ground and operating at a fantastic speed, and getting many Soviet generals very excited. But it was actually the second test a few weeks later that was its undoing. Apparently, this time the vehicle achieved an impressive feat of covering a distance of 10 kilometers at remarkable speed. It navigated through various different types of solid rock, fractured rock, sand, and gravel, and as it tunneled, it melted those materials around it, creating a solid and incredible robust tunnel without any debris in its wake. However, tragedy struck in a catastrophic manner. According to accounts, deep underground, the vehicle met a devastating end, erupting into a massive thermonuclear fireball. This event resulted in the vaporization of its commander and the entire crew, and the disaster led to the complete collapse of the tunnel. Subsequently, any attempt to recover the vehicle's remains was abandoned, effectively marking the end of the program. But did this actually happen, or is this just a crazy Cold War rumor? Fighting underground is actually not a new thing. Records from ancient Greece show many battles and sieges won by sappers undermining the enemy fortifications. Working in secret, these ancient engineers would dig at night and either come up on the inside of enemy walls or by drilling into the fortifications themselves to bring them down. But all of this got a big leap forward with the invention of everyone's favourite black powder, TNT. With explosives, tunneling became a major fear of the enemy, with engineers digging deep underneath enemy lines and even their headquarters, filling the shaft with explosives and then detonating. This was used with huge effect in World War I, with static trench warfare painting the perfect playground for tunneling. One notorious example was the Allied offensive in Messines. Over the following 5 months, an extensive network of tunnels stretching more than 8,000 meters, 26,000 feet for my American viewers, was painstakingly excavated. A substantial amount of explosives weighing around 450 to 600 tons was strategically positioned. The synchronized detonation of these mines occurred precisely at 3:10 a.m. on June 7, 1917, resulting in a cataclysmic explosion that took 10,000 lives. The concussive force was so immense that it resonated windows as far away as London due to its deafening sound. The near-simultaneous detonations, which generated 19 substantial craters, made this event one of the most colossal non-nuclear explosions in record history. But World War I also saw the invention of another type of warfare that would change the game: tanks. Tunnel engineers saw these new lumbering beasts and thought to themselves, why not combine them together? And it's exactly what our heroes of the story, the Soviet Union, did. So in this story, there are some pretty crazy things happening, apart from the apparent lack of evidence that this machine ever existed. First of all, you would need a colossal amount of power to melt rock. This would be a giant nuclear engine, so to speak, bigger than a nuclear reactor and likely bigger than a nuclear power station. Hardly something that wouldn't go unnoticed in enemy territory if you were planning to use this machine offensively. But then even if you had a nuclear reactor, like the ones in submarines, and somehow it got hot enough to melt rock super fast, there would also be a big problem: heat management. You see, there would be no way to cool down the machine or the people inside, because they would be stuck in a tunnel of molten rock with nowhere for the heat to go. Plus, when you melt rock to make a tunnel, the melted stuff has to go somewhere. It can't just disappear, right? Heat management is also a huge problem with subway stations in New York and London. In fact, London, the tube stations have slowly been heating up over the decades, and the heat has never gone away, something that would happen on orders of magnitude greater with our Soviet battle mole. And then we are also led to believe that on the second test, the whole thing had a nuclear meltdown and collapsed the entire tunnel, vaporizing the commander. Pretty dramatic stuff, right? Except that's not really how nuclear meltdowns work. You see, nuclear reactors don't do this when they explode. They have a steam explosion that's a lot slower with fire and brimstone, but not like an explosive charge of a bomb going off, and definitely not enough to completely destroy a 10-kilometer tunnel. And it's that note that I find hardest to believe. I can't believe that the Soviets, having made this miracle machine that could dig tunnels for infrastructure or for combat, would just abandon it after a simple explosion. How many test flights have we seen in the past of aircraft being rejigged after a big error? Why don't they just dig it up, fix the flaws, and rebuild it? After all, it's not like the Americans stopped with their attempts. Surprisingly, while the Soviet story may be just a pile of dirt, the American attempts are actually a lot more concrete under what is known as the Los Alamos Subterrain program. The program would actually produce hundreds of designs, with the simplest being small probes called geoprospectors that could look underground for resources. These little probes were only about 1 foot in width, but would be made of tungsten to withstand the searing hot temperatures that would come from its tip. You see, they would use the ability to melt its way through the rock of around about 0.5 millimeter per second and leave behind a tunnel lined in glass that samples could be taken out of. Several of these small-scale subterranes were based on that fundamental design, and they were constructed and successfully put to the test. But that's not all. The Americans also experimented with bigger ideas. A huge 6-meter machine was combined with both the nuclear cutting with the drill, having a blade on it that heated the rock as it turned. It was proposed to be used for all sorts of engineering concepts, but you know the military applications were not far away. For the Americans, the tech was proven, but there was just no use case for it. In the end, it seems that a water submarine just made a ton more sense. This video was produced in part with research done by the website Skeptoid. Check them out, they're pretty great. And if you want to see more videos just like this one, then click that subscribe button and leave a like and let me know in the comments what I should do next. What happens when the Soviet Union combines a tank with the icy landscape of Antarctica? You get possibly one of the most insane land vehicles ever made. It could face temperatures of -70 degrees Fahrenheit, make its way through snowstorms, carry huge cargo, and still provide a decent accommodation for its passengers. And unlike the earlier American attempts to conquer the continent, the Russians actually had multiple generations, with it serving well into this century. This is the story of the Russian Antarctica tank that succeeded where the Americans failed. The woman from Kharkov, the legendary Kharkov-Shanka.
July 1st marks the beginning of one of the great scientific adventures of our time, the International Geophysical Year.
In 1948, a bunch of Western countries had a party to decide who owned what of Antarctica, considered to be the last remaining vast uninhabited land. But guess who wasn't invited to this party? That's right, the Soviet Union. Naturally, they said, we'll build our own claims to the icy South Pole, and promptly ignored the pie chart. But to enforce these claims, they needed to be there. Anxious to not miss out, the Soviet government created the Soviet Antarctica Expedition, called the, I'm not even going to try to pronounce this name, in 1955 to organize a series of expeditions to Antarctica, as well as take part of the Global Geophysical Year, a study taking place by nations all over the world to better understand the last continent on the planet. Pride was on the line, and it was time to hit the snow. The first Soviet team arrived in 1955 and built 2 small research stations along the Antarctica coast. The first being called the Weaponization Station. To get around, they used typical military trucks that had been used in the Soviet military during the Second World War, because you can bet that they had a lot of them. Whilst fantastic for logistical operations on the front line, they proved to be a little bit useless in the deep snow. But as luck would have it, the team had also packed a few farm tractors that, whilst slow and had no isolation from the freezing conditions, they proved to be very useful indeed. The treads were able to grip on the icy conditions, and the diesel engines provided enough power to drag heavy sleighs around the winterland. It was at this point that the Soviets realized that Antarctica was a nightmare to drive around, and that any further expansion or scientific development in the region, particularly against the rival Americans, would require a new vehicle. Sending word back to the USSR in 1957, the explorers pleaded that they were ill-equipped for the task at hand. They remarked challenges like how the landscape had no landmarks, the compasses didn't work properly, and radios were janky, thanks to the magnetic South Pole. Drivers had to move slow and navigate by the sun and stars when it wasn't snowing or a blizzard, all while trying to not freeze to death. Simply put, they needed better vehicles. With this in mind, the second and much more ambitious Soviet expedition embarked on a journey to Antarctica. During this mission, the teams brought with them robust tracked tractors designed to be equipped with heavy artillery, which surpassed the capabilities of the previously employed vehicles. They were called the ATTs, and they utilized a fantastic platform that was tried and true. It was based on the chassis and drive system of the T-54 tank, one of the most produced land vehicles ever made, and funnily still in service in some countries around the world today. But the ATT was a little bit more different than just removing the turret and cannon. The hull had been rotated 180 degrees with the engine, clutch, gearbox and steering gear and drive wheels located at the front of the vehicle. On the tank, these were in the rear. These new high-performance tractors proved to be significantly more adept and were capable of towing substantial trailers laden with fuel. And notably, fuel was the utmost importance in Antarctica, constituting between 70 to 75% of all of the transported cargo. It was used not only for the fuel for the vehicles, but also as the only reliable source of heat to keep people from freezing to death. The expedition's remarkable logistical support facilitated the establishment of 2 additional research stations that continue to operate up until 2019. Ultimately, this mission concluded its endeavors and returned back home in 1958, leaving a lasting impact on the Antarctica research and exploration mission. But these tank tractors, whilst brilliant, still had some major flaws. You see, while much of the mid-coast had been explored, in the heart of Antarctica, the weather could escalate to even more extreme conditions and had stopped the Soviets from getting much inland. In certain ATTs, occupants found themselves compelled to ignite fires beneath the vehicle to prevent the diesel fuel from solidifying due to the frigid temperatures. And by freezing, I mean that they would have to chop up the fuel like firewood to get it back into the engine. This challenge was far from trivial, as the consequences of the fuel freezing solid could be dire. Ignoring the problems with the engine, the simple fact of exiting the protective cabin to start a fire would be an ordeal for human occupants, given the harsh environment. Moreover, as they ascended beyond 10,000 feet above sea level, the thin air posed to be a significant hurdle, causing numerous engines to falter. The introduction of turbochargers and broader tracks proved with some assistance during the third expedition in 1957. However, what was truly needed was a mobile research vehicle capable of supporting the scientists' life and research activities amidst the unforgiving conditions. To successfully journey not only to the magnetic South Pole, but also the geographical one, the Russians recognized the necessity for a purpose-built vehicle tailored to surmount these challenges. And as luck would have it, the solution had already been built by Uncle Sam. Where the Americans had failed 10 years before, the Soviets would succeed. Or so they hoped, and thus they examined very carefully the flaws of the previous capitalist creation. First of all, any land vehicle in Antarctica would need to be tracked. The US had gone with large tires with little grip, and this had been the main downfall of the 1940 snow cruiser. Plus, this new machine would also need to be waterproof, secured against the elements, and have enough room inside to ensure that they were able to live comfortably in sub-zero temperatures. Plus, matching the Americans by placing the engine inside of the main cabin would allow all repairs to be done without having to step out into the cold. But how would you go about building such a machine? Surprisingly, the answer is simple. You look at the machine that is already operating very successfully in sub-zero temperatures. And by this, I mean aircraft. That's right, aircraft already fly at high altitudes and have a cabin that passengers and crew can live in and work in and operate at extremely low temperatures. And thus the Soviet Union looked for a city in their empire that produced not only tank machines, but aircraft as well, and found it in the Ukraine city of Kharkov. You can see where I'm going here. The Soviets turned to the Kharkov transport engineering plant and told them to come up with the perfect Antarctica explorer, and gave them 3 months to do it. That's right, 3 months. And despite the insane deadline, what they came up was pretty insane. Cue the music. Meet the Kharkov Shanker. Instantly recognized as another derivative of the famous Soviet tank tracks, it had several improvements over the ATT tractors. First and foremost was the complete enclosed cabin that took up the entire space of the vehicle. In here, crew could live and work without having to brave the outside elements, and the entire cabin could be isolated from the cold by 4 inches of synthetic wool between the walls to ensure that only 1 to 2 degrees would be lost per day. But they didn't stop there. Enhancements to the vehicle included a refined 5-speed gearbox paired with a turbocharged diesel engine, now accessible from the inside, boasting a remarkable power output exceeding 900 horsepower. This formidable combination empowered the colossal off-roader to exhibit impressive performance even in elevated terrains. The vehicle's caterpillar tracks, now extended by an extra meter lengthwise and now wider than the original tank tractors, adeptly conquered the icy landscapes and soft snow, whilst its chassis, though lacking amphibious capabilities, featured waterproof attributes and protected well against the cold. Operating at a top speed of 6.8 miles per hour, yeah, I know, the substantial mobile home showcased its might by effortlessly towing 1 or potentially even 2 trailer sleds, carrying a combined weight of approximately 77 tons. But it's the inside environment that's even more fascinating. The Soviets wanted as many comforts as home as possible. Inside the mobile base, the group members had access to a small kitchen, a bedroom that had room for 6 to 8 to sleep, and an aircraft rest room, as well as a vestibule apart from the control section for the driver and the navigator. The vehicle also featured a separate workshop and laboratory, effectively transforming it into a mobile lab. There was also a small dome on the ceiling so the crew could navigate by the stars without having to go outside. Similar to the American Antarctica snow cruiser, the engine was located within the 220 square foot living space, allowing for maintenance without exposure to the elements. However, this design choice led to some issues such as engine noise disrupting sleep and soot from the exhaust fumes covering everything. Yuck! But I'll get to the flaws later. Although on that note, you can imagine that the engine running at night to keep everyone warm would not be ideal noise at all. The driver cabin provided access to the engine while the fuel was positioned at the center of the vehicle beneath the floor. The heating system was situated at the back of the vehicle, with notably, due to the extreme freezing temperatures, the crew couldn't venture outside, making the entire vehicle a vital survival vehicle. A centralized heating system was located at the back of the vehicle, sending heat to various sections. Notably, it was equipped with an electric snow melting device that windows could be heated to give a clear view, and an electric stove in the kitchen that enabled the crew to conveniently heat canned food. It was truly made to survive the elements. This versatile design, combined with its amenities, showcased the importance as a functional and indispensable vehicle for the challenging expeditions to come. 3 were just finished in the 3 months, and it was time to see them in action at the South Pole. And this time, unlike the United States, the USSR could not fail. In 1959, the 3 first-generation monster land crawlers reached the vast icy desert. Their mission? Reach the geographical South Pole via Vostok and prove to the Americans that they were capable to match or even exceed them. 16 men, 2 of the vehicles, and an ATT tractor set off into the icy wilderness, pulling their vast fuel loads on big sleighs behind them. They had no clue what was ahead of them, and with the region totally unexplored, not even from the air. And this is where some major flaws with these new vehicles started to appear. The first was the fast fuel consumption of these land monsters. They burned through a crazy amount of diesel, up to 12 litres per 1 kilometre or 3 gallons per 0.6 miles. At a speed of 6 kilometers per hour, that's an insane amount of consumption. Plus, these improvements to the ATT turned out to be more trouble than they were worth. The larger tracks were complex and broke down in under 1,000 kilometers, requiring replacement over a 5-day period. But that wasn't the biggest flaw with these new land vehicles. It was cold, too cold. The cabin isolation proved to be significantly underwhelming and failed to stop the heat leaking from the cabin. The operators had to run the engines all night, otherwise the 30-degree cabin temperature would fall below zero in just one night. And remember how they had to shut down for 5 days? Well, the engine was the source of the heat, so no engine running meant no heat in the cabin for 5 days straight. But ironically, the engine was also too hot. Let me explain. The oil used for the diesel engine couldn't be cooled enough as it was located inside the cabin. So the coolant couldn't cool down and the cabin couldn't warm up, the worst of both worlds. But despite all this, 20 days later, the team from the USSR reached the South Pole and met with the Americans. And I can't do the rest of this mission's story justice, but my good friend Callum can, and I encourage you to go watch his video about what happened when they met their rival Americans at the bottom of the Earth. I put the video link down below. Flashing forward, for the next 20 years, the first generation of these vehicles served the USSR admirably in the Antarctica conditions. But then the USSR realized that it was time to improve on the design for a second generation. The Soviets had the technology, they could rebuild it better than ever before. The second generation had some notable differences. First, it was actually a return back to the previous ATT design, with a prolonged external engine and cabin. The ATTs had been in use all this time alongside the Kharkov Shankers, and through some successive upgrades had seen them start to be preferred to the first generation. The extended bonnet would allow much better access to the engine, so no more 5-day repair jobs, and allowing for cooling and heating to be applied without affecting the other. Plus, the rear cabin on the back got a major overhaul as well. First, there was much better isolation from the walls of the passenger compartment. In the first generation, bolts had been driven into the space to hold the structure together, but these bolts had gaps between them, allowing cold air to sneak in. And don't forget the diesel engine noise problem. With the engine outside, the team created an auxiliary engine that could be run independently of the main motor, meaning they could switch off the engine and still run heat and electricity in the cabin. By the fall of 1975, another 3 of the second generation vehicles rolled off the same production line and were sent to Antarctica to be put to work. They quickly gained the reputation of being warmer, more comfortable, and preferred to the first generation machines. The Soviets would use them over the next 20 years to expand their presence throughout Antarctica and to run various scientific missions with other nations. And with 2 generations down, the Soviets thought to themselves it was time to upgrade to a third version that would be even more insane. Now, I'm going to be such a tease here. The third version was never built. Alas, it's this part of the story that gets a little bit sad. A major event happened during the development of the third generation that would change everything: the fall of the Soviet Union. There was no longer any money, and the new Russia was seeking its destiny in the Northern Hemisphere. A third generation for a machine that was now a world away seemed utterly pointless. And just like how World War II killed the American snow cruiser, so did the fall of the USSR did for the Kharkov Shanker. So the remaining 6 vehicles would be utilized throughout the new Russian operations in Antarctica very much into recent years. And again, Callum, my very good friend here on YouTube, has done an excellent end of mission report about whatever happened to these vehicles down at the South Pole. So I'm going to put a link in the description here so you can go check out and see everything about it. Of course, I'm not going to just leave you feeling like this. There's the next generation vehicle that they did plan, called the DT30, that I'll have very soon here right on the channel. So if you want to see that, subscribe and leave a comment down below, and I'll see you in the next Found and Explained. Laser tanks. Yes, you heard that right. Laser tanks are the real deal, and they've been around for more than 40 years. So what the heck happened to this idea? During the peak of the Cold War and Reagan's Star Wars initiative, the Soviets actually developed sci-fi-like weapons under the veil of absolute secrecy, and the results were several iterations of tanks with weaponized lasers. But their actual combat use and the story behind them might not be what you expect. Let's shine the light on yet another insane Soviet project, but one that actually came to life. In 1991, the CIA received reports of a new type of tank rolling out to the Soviet army positions, and at first, they were baffled by the reports. Called the 1K17, it was huge, and based off the bones of an artillery tank, it rumbled and shook the earth as it moved with its advancing troops. But this hunk of metal wasn't designed to be offensive, but defensive. With 12 powerful lasers, each that could operate separately, it could target the advancing machines of the enemy, such as helicopters, jets, and tanks, and disable them, overpowering their optics and blinding their operators. But it didn't stop there. It could also track and quickly take out approaching missiles, making shoot-and-forget air forces, the doctrine of NATO at the time, obsolete overnight. And that fact terrified the West, that the Soviets had taken what was essentially a fantasy and turned it into an actual weapon that, if used, would be a war crime. But to understand, we have to go back a few years to the very start and how the Soviets even came up with this insane idea. Lasers are a massive sci-fi trope and somehow always connected to futuristic weaponry. The 70s and 80s ushered in an era of pop culture that made them super popular with movies, especially with the likes of Star Wars. Everyone believed that the future of warfare was going to be modeled by high-energy weapons. Just don't give them to stormtroopers because they're pretty useless. Whilst it was fiction in America, the Soviet army was hard at work at making it reality, developing the actual laser tanks. And to the shock of the US, they had no idea what they looked like or what their overall purpose was. And this was quite the curveball. You see, in the 1960s, the Western Armed Forces had an optical revolution sweep their armies. Both ground and air vehicles saw the arrival of night vision and even rudimentary thermal imaging devices. Unable or unwilling to keep up, the Soviets started taking a different approach to this new technology, countering it by using powerful lasers to disable the optics and take out the operators using them. And I mean, take out for good. Thus, in the early 1970s, a scientific development center named the OKB Radunga was created in the secret city of Vladimir 30. I swear to God, this is not a plot of a James Bond movie, with the main goal of developing high-energy weapons. By 1978, it was turned into the NPO Astrofizika, or Astrophysics, helmed by chief designer Nikolai Ustinov, none other than the son of the defense minister Dmitry Ustinov. So, as you can guess, money wasn't the issue and the plan was full steam ahead. And again, it really does sound like the plot of a James Bond movie. However, this wasn't just another case of nepotism to burn cash, because in 1982, the first laser tank was actually built. Called the 1K11 Stiletto, this was based on an engineering vehicle and had a powerful single laser emitting turret on top of it. Its main purpose was to detect glare of enemy optics at long ranges and automatically emit a laser to counter them. This would fry any optic on a vehicle, helicopter, or even a laser guided missile in a range of several kilometers. But the turret of this vehicle was very slow, and even though it officially entered service in the Red Army, it soon followed by another improved design. The SAG-VIN was based on the Shika chassis, and it featured a radar and a much more powerful laser emitter with a range of up to 10 kilometers. It could work against either targets detected by glare or radar, and it was so strong that not only optics would be fried, but also the retinas on the pilot's eyes or tank crews, blinding them and preventing them from doing, well, pretty much anything. And this, children, this was a war crime. Development was put on hold for several years as Ustinov Jr. moved on from the Bureau, but then by 1991, breakthroughs in energy technology led to the ultimate variant of the laser tank. This new vehicle was based on the 2S19 Mr. S chassis, a self-propelled artillery vehicle with a massive turret, and this was for a very good reason. You see, the flaw with the previous iterations was that it was just one laser and it could only emit on one frequency, so the Americans could get their hands on this frequency, add a simple filter over the optics, and block that frequency and make this weapon completely useless. So that's why the 1K17 featured not one, but 12 different channels, making any countermeasures obsolete. They could also operate autonomously, engaging in several targets at once and switching at a moment's notice. Apart from the 12 lasers, it also featured a target detector and night and thermal visions for the crew. Thanks to its large vehicle turret, it could accommodate all of the electronics, and even more importantly, the generators that could power this extremely hungry machine. And this is where it starts to get a little bit wild. Myths floated around that a massive 30 kilogram ruby crystal was a conduit for the high energy beam, but that's totally nonsense. And probably a YAG laser technology was used, which was outside the visible spectrum, operating in the infrared spectrum, so you wouldn't even see the tank operating until it was too late, and then you couldn't see it all. And yes, the 1K17 laser was probably strong enough to damage or completely destroy retinas of the pilot or vehicle operator, which again is against the Geneva Convention. The Soviets would also add a machine gun on top, but there wasn't any real protection because this sort of vehicle would definitely not go into direct combat, but rather stay behind and play a supporting role. There is information out there to suggest that during the testing of the laser, it once knocked out a helicopter's optical system at a range of 6 miles. Sounds pretty wild, huh? Well, there were several issues with the design. First and foremost, even with the 10+ kilometer range that the previous vehicle had, it would need it to be 10 kilometers unobstructed. And in a real combat scenario, that's not going to happen. There'll be trees, mountains, and even dust that would be an obstacle for the laser beams. And with thermal optic technology getting better and better, the vehicle emitted heat like crazy. Modern tanks would spot it and engage at extreme long distances. And as ATGM switched from laser to radio guidance, it would have a hard time defending against threats in any slightly mountainous terrain. Yikes. And also, part of the design flaw was that it could only fire the lasers in the direction that the turret was facing. And as we know with the T-90 that Russia uses today, it's not in a very effective way in combat. And last but not least, this sci-fi laser tank came at the wrong time. With it being built in 1991 and entering service in 1992, there was absolutely no money for crazy projects because the new post-Soviet Russia, well, was falling apart financially. With the collapse of the Soviet Union, the development of the tank was abandoned, as the development and manufacturing of the laser projection system had become too expensive and unnecessary. It truly was the second most expensive tank ever built, technically behind the NASA crawlers used to carry the shuttle at Cape Canaveral. The 2 prototypes were scrapped, with one ending up in a museum, missing its laser technology. But this vehicle is still listed in service with the Russian army, and it was never removed from its top secret list of projects, with the Russians even today guarding its technology fiercely. Why? The Soviets would develop another laser weapon called Yakolev and tested it in the 80s on ships. This was the same laser from the second laser tank, but it served a different purpose, defending the ships against the missiles at the time. However, the Russians wouldn't stop there. They would then develop a Cold War airborne laser platform on the Bartini A60. It would have a top secret use, which we'll do a video about it into the future. Lastly, the Soviets would also use the laser technology under a program called Sokol Echelon. This would be an airborne laser that was used in 2009 to illuminate a Japanese satellite without damaging it, and do so successfully. The idea behind it that it would be used to not shoot down satellites, but to blind them, just as the laser tanks were purposed to do. This would explain why the Russians have been so coy about revealing any technical data about its laser tank projects. And that's why I don't have any information about just how powerful these lasers were on the tank. Have the Russians actually developed a secret superweapon and simply put it on ice until an all-out war against everybody? Or is it yet another Cold War era project that will only live up in a book or movie or a found and explained video adaptation at some point? Let me know down in the comments, and also let me know if you want me to do a video on the airborne laser systems like the Bartini A57 and the Boeing YAL-1. Regardless, I hope you enjoyed this one, and be sure to subscribe for more interesting projects that will continue to bring you on Found and Explained.
Is it a plane? Is it a tank? Is it a glider? Well, let's just say it's a combination of all three. The World War II era Antonov A40 was a mind-boggling combination of machinery that was part plane, part tank, and even part glider too. The Nazis may have been the leaders in slightly demented military machinery during the Second World War, but this Soviet plane/tank was right up there with some of the most optimistic and a little crazy Nazi German inventions. But if you could apply one rule to the Soviet or German crazy World War II project convention, that would be just because you can doesn't mean you should. Let's jump into it. I've covered quite a few weird and wacko flying machines on this channel, but a few as quite as weird and wacko as the one I'm going to talk with you about in this video. This one takes quite a bit of beating in the Bizarro stakes, trust me. The concept of the Antonov A40, which was sometimes referred to as the A40T or KT, was actually quite simple. Devise an aircraft that doubled as an armoured vehicle too, so that it could swoop into a battle zone as quickly as possible, then once landed the aircraft could detach its wings and transform itself into a battle-ready tank. However, the chief purpose of the A40, which the Russians dubbed the Krylia Tanka, or tank wings, was the ability to fly tanks into needed battlefields as quickly and efficiently as possible. Mobility and flexibility were key to the A40 design concept. The assumption was that the flying tank could detach from its towing aircraft some 20 to 26 kilometers or 12 to 16 miles from the target, and then glide silently down into the battlefield where it would engage the enemy. The aircraft was specifically designed to operate as an engineless glider and thus fly stealthily and at low altitude into the combat zone. The bulk of the craft would be one of the lightest Soviet tanks available, the T-60. This particular light tank was considered an excellent choice by the Soviets, given that it was easy to mass produce and could be assembled in automotive factories using a wide range of automotive production assemblies and parts. It was compact in its dimensions and had what was considered a manageable weight. Also, the tank only required 2 crew members to commandeer it. On the ground, the tank could move up to a speed of 45 kilometers or 28 miles per hour, with a total of 6,045 T-60 tanks produced in the war from 1941 to 1945. But this special version would have had fabricated biplane wings attached to it, as well as a twin tail for much needed stabilization. The biplane wings were made of ultralight plywood and fabric, with a wingspan estimated to be just over 18 meters or 59 feet, as well as an overall area of 85 square meters or 923 square feet. Each biplane wing would be unstaggered and feature a pair of tail booms with twin
thin vertical surfaces and a high-mounted single horizontal surface. Aerodynamic controls for the craft comprised of a single lever that operated all flying surfaces from the driver's position. Or I suppose in this situation, the pilot technically. The A40 would immediately drop the cradle to which the wings were attached once the tank was deployed onto the battlefield. The designer who dreamt up this mad design would be none other than, let's hope that I get this right, Oleg Konstantinovich Antonov. This was indeed the celebrated father of the Soviet Union's aviation industry, the very same after which so many famous Soviet-era aircraft, both military and commercial, were named. Interestingly, until then, Soviet forces had been strapping tanks and armoured cars to the bottom of TB-3 bombers, and then dropping them from very short heights onto the ground. The tanks would not break apart on impact as long as the gears were in neutral. The drawback was that the tank crews had to be dropped separately from the tanks, which delayed the deployment of these tanks once they were on the ground. Also, the tanks being deployed were simply too small to be very effective in combat, nor was it worth risking a bomber just to put them into the battle. But why this need by the Soviets to deploy their tanks in such an unorthodox manner in which speed of deployment was everything? There's no denying that the Second World War was the veritable hothouse of some of the most inventive and daring aviation designs and engineer concepts ever devised. Necessity is the mother of invention, as the saying goes, and it wasn't only Nazi Germany that was desperate to gain the upper hand in the air during the war. The Soviet Union was waging a staggering bloody war against the Nazis on the Eastern Front and were equally desperate to attain any gains possible, including aerial advantage against the Nazi Germany's formidable Luftwaffe. And, as already noted, the Nazis had their nimble powerhouse panzers on the ground that were proving a tough match for the Soviet forces. Nevertheless, defeat was not an option for the Soviets, which is why no military concept was off the table. By the way, the Soviets only commissioned this designer to build his flying tank in 1942, which coincided with some of the worst fighting of the German invasion of the Soviet Union. That leaves us with the question, what happened next to this flying tank design? The first prototype of the aircraft was built in 1942 and was indeed tested on September 2nd of that year. The pilot chosen for the A40 test, Sergei Anohim, a famous Soviet experimental pilot. If anyone could pull it off, it was our man Sergei. Initially, the aircraft would need to be towed by another aircraft until it could glide down into the battlefield. There was just one little problem. Gliding with a 5.8-ton tank attached to its wings is not the most aerodynamically thing to achieve. The test A40 was to have been towed in the air by a Tupolev TB-3 bomber, however it wasn't exactly a success. Once the craft had reached around 160 km per hour, or just under 100 miles per hour, the sheer drag was simply too much for the wooden biplane wings. Sergei was losing control and was forced to ditch the wings and opt for a so-called soft landing inside of a 6-ton tank. Whilst very shaken, he only suffered some light injuries, but was immediately detained by the Red Army soldiers at the ground who had not been advised of an odd-looking vehicle and declared it to be a combat danger. It was also reported that the TB-3 bomber towing the tank overheated itself and nearly failed immediately after takeoff. So why was the test such a failure? First, the wings were simply too big and not sturdy enough, since they were made out of wood. Second, it was necessary to remove ammunition and fuel from the tank in order to make it lighter for flight, which pretty much defeated the purpose of the tank as an all-out combat armored vehicle. According to some sources, even the tank's turret was also removed in order to save on weight. That would be somewhat problematic for a tank driver in the heat of battle. A third reason for the A40's failure is that the T-60 tank used could only be armed with a 20mm cannon and 10 to 25mm armor. The Soviet tank was simply too weak for its required role against powerful German tanks on the battlefield.
It was later ascertained by the Soviet military analysts that a far more powerful aircraft would have been needed to raise the A40 to the required height in flight. That aircraft would have been the PE-8, a powerful strategic bomber used by the Soviets for deep air raids and the bombing of Berlin during the war. But here's the catch. The Soviet Union only had 80 of these bombers, making the A40 project even more logistically non-viable. That would be the one and only test done of the Russian flying tank. Even with the failure of the A40, the Red Army continued to work in the field after the end of World War II, which resulted later during the Cold War in the successful family of tanks that could be airdropped and which also have amphibious capabilities, the BMD. In the end, it seems, the flying tank concept wasn't that crazy or harebrained after all. The Nazis have nearly captured Moscow, but then a new Soviet tank appears on the horizon, unlike anything they have ever seen. And its proportions and armament are ridiculous. This monster tank rode into battle on an extra long tank bed, allowing it to field 5 big cannons, 18 machine guns, 15 rocket launchers, and just for overkill, 2 flamethrowers. But behind the crazy story of this super tank is an even crazier truth, one that we need to sort from fact or fiction. In today's lighter episode, we'll be looking at one of the most insane tank creations ever dreamed up, both real and fake, and exploring what could have been. Roll out today with Stalin's Orchestra, the Soviet land battleship, or better known simply as the KV-6, Behemoth. In July of 1941, Stalin was informed about a tank that single-handedly held off an entire 6th Panzer Division at the Battle of Rasane on June 24th. The tank, depending on the sources, was either a KV-1 or KV-2. The Battle of Rasane was actually a disaster for the Soviets, but the KV-1 in general proved to be able to handle German tanks well because it was well armoured. Further variants were also made with better guns and manoeuvrability to counter the rising tide of German Tiger and Panther tanks, and the KV was chosen as a basis because it proved to be as good tank in the first stages of the war. Now, the interesting development was that each of these tanks was designed around the same chassis, turrets and engines, necessitated by the urgency imposed by Stalin and the strains on the Soviet industry caused by the German invasion of Russia. Apparently, the engineers at this point realized that if they put all the components together, they could create one giant tank. It would take the same amount of time to build, but would have considerably more firepower. Thus, the Behemoth was born. Dubbed as a land battleship, this tank would have had 3 major turrets over an elongated tank tread, approximately 51 feet long. Despite concerns from designers about the impractical length of this vehicle, due to the insistence on 3 turrets, Stalin dismissively declared, "It doesn't need to turn, it will simply drive straight to Berlin." Due to its considerable weight, the tank was also equipped with wading devices enabling it to traverse rivers up to 9 feet deep. Additionally, a removable observation tower was designed to direct fire of howitzers and rockets for when the tank was in a turret down position. Now let's talk all about its firepower. It would have a normal KV-1 turret at the front of the tank, although with double 14.5mm autocannons in the smaller turret on top. Behind it was the main turret, a modified KV-2 turret armoured with not one, but 2 152mm cannons, with a smaller BT-5 turret on top of that armed with a 45mm cannon. The ammo for it was stored behind in the turret. The rear turret would again be taken from a KV-1 armed with a 76.2mm gun, but with a twist. On top of it, there would be a rack of Katyusha rockets that would be mounted for extra firepower. Of course, there were also several machine guns throughout and 2 flamethrowers at the front.
To operate such a large machine, the engineers proposed 15 crew members with two powerful 16 horsepower engines at the rear. Despite its power, the top speed was only 13 miles per hour thanks to how heavy and how fuel hungry it was. But with this crazy design, it earned the nickname Stalin's Orchestra from the few Germans who encountered it, owing to the array of weapons that it deployed. So in this historical account, did this tank ever see any action? Well, apparently, 3 were built. The first prototype, allegedly completed in December of 1941, was hastily deployed in the defense of Moscow. During its inaugural action in dense winter fog, the rear turret accidentally fired into the center turret, resulting in a catastrophic explosion that obliterated the vehicle. The second prototype, finished in January of 1942, was sent to the Leningrad front and featured indicators on the turret aiming sights to prevent it from firing on itself. Unfortunately, it broke in half while crossing a ravine, unable to sustain the weight of the central turret, and had to be blown up to prevent capture. The third prototype, reinforced and sent to the Leningrad front in early 1942, managed to shoot down 3 German aircraft using its autocannons. However, during its first ground engagement, all the guns fired from the 3 o'clock position simultaneously, and the tremendous recoil caused the tank to tip over sideways into a ditch where it was immobilized. Following these setbacks, Stalin terminated the project and refocused efforts on just producing multiple smaller tanks to outflank the enemy. So let's have a little break to talk about this tank and be an armchair armored expert into why such a wacky design couldn't possibly exist. Honestly, there are so many flaws with this design that I just don't know where to begin. For one, it was so heavy and fuel hungry. It would be so slow to get to the front lines operating at that tiny top speed, and it would also require a constant train of fuel trucks to refuel it. Also, it would struggle to drive over any terrain. Even pure concrete roads would crumble under its sheer weight, and I don't want to even think about mud or swampy conditions. They said that it could wade across a river with some special flotation devices, but I find that incredibly hard to believe for such a heavy vehicle. Simply put, there is no point to have a treaded vehicle if all the ground has the consistency of peanut butter. There are also so many points of failure with this machine that any mechanics watching would realize that it would be in the shop year round. You've also got to see this from a strategic point of view, that it was majorly weak to one significant threat: aircraft. You could spend weeks building this tank that could go up against the very best Nazi armor, but a single plane could pound it into oblivion, and the sheer size of this tank made it an instant target on the battlefield. Plus, I love to imagine the sheer logistics of being this tank commander. How would you exactly aim and fire this tank with so many crew members and so many different rotating and moving pieces? Would the commander be like target A, attack, and then turret 2, target B? It would be a headache for anyone involved. Plus, I imagine if the tank needed to be recovered from the battlefield, you would need a serious tractor to pull it out of the mud. And I think for all intents and purposes, it's very obvious why this tank could never exist. So where on earth does this idea come from? Well, I have some bad news. It actually isn't from 1942, but rather 1995. A model maker by the name of Brian Fowler decided to have a go making a new inspiration of a Soviet tank using spare parts from his model kit. And then of course the internet got their hands on it, with DeviantArt user Von Breuer made a whole history to go along with the pictures, including much of the work in today's video. Now, I get it, you might think that this is a little unfair that we didn't spill the beans till the very end of the video, but it's a fantastic concept tank, and I think we can all agree that the only difference from its creation from a model maker to an actual engineer in the Soviet army is just time. After all, World War II dictators were pretty wacky, and very likely, had they known about this concept, they would have asked for it to be put on the front line. And of course, by this, I don't just mean Stalin. If you think this was just a joke and could never work, well, I have some bad, Or rather, good news for you, because the Nazis actually proposed several iterations of a super heavy tank by the end of World War II, which we've actually already covered here on the channel in a separate video, so you can go watch it here right now. Thanks for watching.
In the height of the Cold War, the Russians developed a new type of super heavy tank. One that could fight over any type of terrain, reaching areas inaccessible to conventional tanks, powerful enough to break through enemy front lines, and if necessary, withstanding even the shockwave of a nuclear explosion. But this tank never saw any action. Its prototype was cancelled and scrapped right before production, and it was only ever given the mysterious name of Object 279. Hold up. This is supposed to be an aviation channel. I subscribe for planes only. I only want planes. More planes. Now trust me, this video will be just as good as my regular content, so strap in and let's go. After World War II and the grand entrance of atomic weapons used in Japan, the world realized that warfare would never be the same. These new powerful bombs would allow conventional forces to be wiped away instantly and front lines to shift dramatically. Thus, any new military land vehicle under development would not only need to be fast, able to traverse inhospitable terrain, it would also need to be able to withstand a distant nuclear blast. And with Russia being Russia, they were quick to come up with a solution. Developed in secret at the Kharkov plant in Leningrad in 1957, this new heavy tank would act much like the heavy tanks of World War II, such as the German Tiger I and II and the Soviet JS-2 and 3, destined to fill the ranks of the Supreme Command Reserve. This project would remain unnamed, only appearing in files as Object 279, and this is the tank that they came up with. Object 279 would be a super heavy tank, weighing over 60 metric tons and be 6.77 meters long, which is around 22 feet, and 3.4 meters wide, which is around 11 feet. It was also 2.6 meters tall, 8.7 feet. It would have a crew of 4, including a driver, a gunner, a loader for the gun, and a commander. Now, you might have noticed something very different about this tank. Let's talk about those 4 tracks. This tank featured a 4-track running gear mounted on 2 longitudinal rectangular hollow beams, which were also used as fuel tanks. This design would actually spread the weight of this heavy tank over a larger surface area, resulting in 0.6 kilograms per centimeter squared, or around 8.5 psi. This made it perfect for cross-country capabilities on swampy terrain, soft soils, and areas full of cut trees. It would also be able to go completely through anti-tank obstacles, like the hedgehogs that you can see here, something that many other tanks would have failed to traverse. Its weapons system was also advanced for the time, featuring a 130mm cannon with a semi-automatic loader with 24 rounds, infrared sights, and even a radar rangefinder. It also had a machine gun with 800 rounds. Now when it comes to armor, its frontal protection was as thick as 11 inches, which compared to its contemporary at the time, the American M60, that only had 6 inches. Its unique oval shape was designed to protect it against blast shockwaves, such as a nuclear weapon, preventing the tank from flipping over. The whole crew compartment had full chemical, biological, radiological, and nuclear protection, as well as heaters and air conditioning for comfort. The whole tank had a powerful 1,000 horsepower 2DG V8M diesel engine, giving the 60-ton tank a top speed of 55 km per hour or 34 miles per hour, and a range of 300 kilometers or 186 miles on a single tank of gasoline, which is fairly impressive for how heavy this tank was. With the prototype finished by 1959 and testing on the firing range, it seemed like the tank of the future had finally arrived. So why was it never put into service? One of the key reasons why this heavy tank project and other research into designs like this was abandoned, and why the Object 279 never made it past this prototyping stage, was that the Soviet military in 1960 chose to stop operating any tanks over 37 tons, which also includes any additional attachments such as minesweeping or smoke bombs. As this type was over 60 tons, it never stood a chance. And this was because there was a push from Nikita Khrushchev himself to adopt alternative land military vehicles, such as guided missile tanks like the IT-1. He felt that at the time that World War III, if it was to happen, would be all about high-tech weapons of war, and that a simple heavy tank would be easily defeated by some sort of new hovering or flying monstrosity. There was also another drawback with the weight of the Object 279. Whilst the treads allowed the tank's surface area to be much greater and the pressure to be lower, and it would be able to operate easily on anything from sand to snow, it did actually have one limit: bridges. Notably, bridges that were throughout regional Russia that could not hold such a large tank, because even though the tank has a large surface area, it still weighs 60 tons. If the Russians found themselves in a war and had to retreat through their own home country, they would struggle to get their own tanks over their own rivers. And lastly, this might be the real killer: Object 279 was too darn expensive. The tank burned through fuel when moving through swampy areas, it cost a ton to build, repair, and maintain, and it was impossible to make it shorter. Its turret would stick out over the landscape and be an easy target. Today, there is still one of the 3 non-functional prototypes in a museum in Russia. And that leaves us with a what-if question. Would Object 279 have proven effective on the battlefield? Despite the fearsome reputations of vehicles like the Tiger during World War II, they actually ended up becoming maintenance hogs. Whether a complicated design like the quadruple-tracked tank in a fast-paced mechanized war in Europe would have been game-changing is an open question. But chances had the Cold War become hot, no American tank crew would have enjoyed facing the last Soviet monster tank. Today's tanks have evolved to be fast and serve a central role in military forces. There are a few distinct light or heavy tanks, and with the use of nuclear weapons considerably unfeasible, tanks no longer really have that design limit in mind. Instead, we have tanks that have a central role in a mechanized division and are able to fill the heavy and light roles simultaneously. Object 279 remains as a relic to a time when nuclear war was not only seen as likely, but inevitable, and I for one am happy it was never built.